Good morning, everyone. Welcome to the day 9 of the Faculty Development Program on Python Programming for Engineering Applications, jointly organized by Electronics and ICT Academies at IIT Guwahati, Triple IT DM Jabalpur, IIT Roorkee, MIT Patna, and MNIT Jaipur. Today we have Dr. Saurabh Srivastava sir as an expert for the session. So before handing over the platform to sir, let me give a brief introduction of him. Dr. Saurabh Srivastava has over 6 years of experience in industry and academia with roles spanning across development, planning and architecture of IT solutions. The responsibilities assigned to him include teaching assignments, administrative duties, and hands-on product development. He has worked in organizations with varying profiles, including the prestigious Space Agency of India, ISRO. His area of expertise includes software architecture. His area of expertise includes software architecture and engineering, as well as AI intensive systems. He is passionate about planning and building software systems to automate business processes. He holds a doctorate and master's degree in engineering from the Department of Computer Science Engineering, IIT Kanpur. He is currently serving as an assistant professor at the Department of Computer Science and Engineering at IIT ISM Dhanbad, with the functional position of professor in charge of automation of institute processes. With this brief introduction, I would like to hand over the platform to Dr. Saurabh Srivastava, sir. Over to you, sir.
Okay, good morning and thank you for the introduction. So, hi everyone. I could see there are quite a lot of participants in the participant list. So, good morning to all of you. Let me start off by sharing my screen. I think it's already shared with you, right? I hope you can see my screen as of now, right? Um, just certain things from my end before we go ahead. When I usually teach, I teach in a flow, right? So it is quite possible that I don't look at your messages. It doesn't mean that I'm rude. It's just that when I'm teaching about something, I just teach in a flow. So it's quite possible that I might not be able to look at the messages that you have. So in such a case, it's perfectly fine that you can unmute yourself and you can stop me if you are interested. You don't have to wait till the end of the lecture to ask me queries. So whenever you have some doubts, you want to talk to me, or you want to have some discussions, you can just unmute yourself and talk to me, because I will be having my screen in the full screen mode. So I might not be able to check up your chats, right? I don't know how things have been in the previous sessions, but with me, you can just raise your hand. I mean, probably I won't be able to see a raised hand in the full screen mode, so you can always pip me if required. Okay. So with this, let us start. So again, as I said, if at any point of time, let us say my screen freezes because we are doing this in an online mode, it's quite possible that sometime the internet breaks. We are living in India, we are not really in a first world nation. So if something goes wrong, right, just try to ping. I understand that if the internet is not working, you won't be able to get to me. But the moment I'm back on the internet, you can just ping me and say that something has been lost, or you have any other problems, right? So the idea is, don't wait for me to check your messages. Just start off, just unmute yourself and ask. Okay. All right, so let's start. So this is day 9. I hope you have learned a lot in the first 8 days. And since we are talking about Python as such, I'm quite sure that by now you guys know more Python than me. And I'm not kidding. The reason that I am saying that you probably know more Python than me today is because I'm not exactly a Python programmer, right? I used to be. I mean, in fact, 5 years uh, down the line, right? If let us say in 2020 or something somebody had asked me to take up a session on Python, I would have laughed, right? I said, no, I don't have any knowledge at all about Python, and I don't think I'll be able to take any sessions on Python, right? But things have changed. The world has changed, and one of the major reason of this change is what we are going to discuss today: the concept of LLMs. Right? This is a kind of a revolution that has made not just Python programming, but programming in general a lot easier for people who are not particularly from the CSE or IT background, right? So it is this so-called revolution that has driven this change. Today probably I don't even need to know all the intricate details of the Python syntax. Of course, you need to know what exactly is it that you want, right? But as long as you understand what is required from your end, from there onwards, probably an LLM can help you with generating code, right? So today's session, and of course I'm assuming that all the basics related to Python has already been covered, because we are now in the later stages of this faculty development program, and I'm pretty sure that you understand that now we are just talking about applications, right? And what are the places where Python has brought a significant change. So, with this premise, let us start. So, as I said, this whole day we are going to talk about LLMs. So, it makes sense to formally introduce LLMs first, because I had gone through the curriculum of this FDP. I realized that this was more of a Python programming focused FDP. So, there was really no specific session which talked about AI or ML or something like these. So don't worry, we don't need too much of AI and ML as of now. Whatever is required, we are going to cover in this particular lecture. So let us start with this very basic introduction to what are LLMs. So as almost all of you would possibly be knowing, the full form of a large language model, sorry, of LLM is large language model. So let us try to just go through these three words one at a time and try to see what exactly is happening here, right? So we'll go from right to left, right? So let us try to see what exactly is a model, right? So as I said, even if you do not have any background in machine learning, I'm pretty sure machine learning would have at least touched your life at some point of time. If you are in any kind of technical field today, it's quite hard to actually not been to not have been come into the ambit of machine learning. So typically, model is a term that became more popular as machine learning grew, right? So this means that somewhere towards the end of the decade of 2010, right? It was at that point of time. I mean, machine learning existed probably for decades before that, but it was only when these deep neural networks started showing real promise that this so-called term model, right, it became more popular, right? So in today's term, what we can say is essentially a model for most cases is just a collection of certain weights. I mean, this is probably not the best of the definition. It's a very crude definition, because typically in a model you also have some hyperparameters which are also stored as part of the model storage. But for a layman, the only thing that for now we will consider is that a model is simply just some weights. So for example, this is a very simple example of a neural network. If I want to create a neural network that tries to predict a comfort score, right? Comfort score means what exactly does the weather look like today. So based on that, these are some of the inputs that I would need, and then this is also known as a hidden layer. So a hidden layer is essentially a place where you take in some inputs, you do some processing, and then you just send whatever processing you have done to the next layer. So it's a very simple example, and basically whatever I get here, this so-called score, is the output of this so-called neural network, right? So what exactly is a model? Essentially, all the information that you see currently on your screen, right? If you want to store this information in an efficient fashion, as in, if I want to simply recreate this network from scratch, right? So then what are the pieces of information I require? This essentially is a model. So in this case, for example, you would need things like how many layers are there, and how many neurons are there in each layer, and then what are the weights to all these edges. So let us say if I have a efficient mechanism to store this information somewhere, then whatever I store, that is considered as a simple model, right? So now let us take one more step back in this so-called large language model terminology, and now discuss what is a language model. Right? So a language model is a model that has the capacity to understand the structure as well as, let us say, the meaning or semantics of some particular language. Right? Keep in mind that the language term that we are using here, it is not the programming languages, they are the natural languages, languages like English, Hindi, Sanskrit, whatever it is, right? So whenever I talk about a deep learning model, typically it is associated with deep learning, although there's no hardcore definition that it has to be a deep learning model. But almost all the language models that you will come across today, they are basically models which are supposed to create a deep learning network, right? So in the simplest form, in a language model, as I understand, as I told you, is something that understands the language, right? It has the capacity, it has the ability to understand some particular natural language, right? And in the simplest form, right, the most common way in which people use a language model is to predict the next word. So what does it mean by predicting the next word? If I give you some words, right, some 4 or 5 words, and then I ask you, okay, tell me what is the most likely next word, right? This is something that we use as far as this is probably the basic assumption which is required for building a large language model, right? So let us say if I have this as input, the cat sat on enter. Okay, so these are 5 words which I have already seen, right? So this is the input to a so-called language model. A good language model will be able to give me an output which looks something like this. So what exactly is this? Essentially, I have a vocabulary, right? So a vocabulary is basically the set of all the words. Again, I'm using the term words here, but word is probably not the best term. The real term is tokens. So sometimes these tokens are at the sub word level as well. So it is quite possible that my so-called LLM might actually split bottle into BOT and TLE, or BOTTLE, something like this, right? It's something that we are not really concerned at this point of time. But the idea is, in a typical language model scenario, language model use case, the input is a set of tokens, right? These are, and by the way, the sequence is also important, right? They are being seen in exactly this particular sequence. It's not a bag of word kind of thing that they can appear in any particular sequence. No, the sequence is important. So a typical language model, what will it do? You give it a set of words or tokens that you have seen till now, and you give it a vocabulary related to this particular language, right? This language model is going to be dedicated for some particular language. So let us say if it is dedicated for the English language, we are talking about a vocabulary of all possible English words, and you can already see where this is going, right? The number of words, the number of tokens that are possible in English, right? Just imagine this number, what a large number this would be. And then what is the job of this so-called language model? Its job is to output a table that looks like this. And what exactly are these? These are some probabilities, right? So when I say that mat has the probability 0.9, rat has the probability 0.8, sky has 0.02, bottle has 0.2, what exactly is it that the language model is doing for me? It is essentially creating a kind of a probability map for me. This so-called probability map can then be used to come up with the most possible token, right? The most possible token is like the most probable token that is probably going to follow. this set of input, right? This set in this particular sequence, right? So when I say the highest probability is with the token mat, the next word predicted by this language model is going to be mat, right? So now what does this whole sentence looks like now? The cat sat on the mat. Okay. So now we have understood what exactly is a language model. A language model is basically anything that has the capacity to understand a particular natural language, for example, English. So now what exactly is a large language model? Of course, the definition is quite simple. A large language model, any questions? I hear something. Any queries? Okay, I thought I heard some. Right. So a large language model is basically a language model that is large. Yes, it's not much of a description, but to be honest, that is precisely what it is, right? It's a language model.
Dear
Can I
sir,
still? Yes.
sir,
Yes, please.
in a large language model, what exactly meaning of the large here?
Yes, yes. We'll just come to this. Okay.
Okay,
So
okay.
so right. So that is the it's a very natural question that you had, right? So what exactly does the large part really mean, right? When I say this language model is large, right? So the large may refer to multiple things, and usually, right? Usually, for a large language model, all these will be there. I mean, I'm saying that even if one of these things are there, I'll probably call it a large language model. But it is seen that usually you will find all these three things together. So what is going to be large in this so-called large language model? The first one is the model size. So I showed a very simple example of what a neural network looks like, right? And in fact, let us go back to that picture that we had. So let us say if I want to somehow capture all the information that is required in order to recreate this model, I'll probably need to store one, two, three, four, five, six, some six weights, and then plus two, eight weights. Then possibly I need to store the number of layers, that is another parameter. Then the number of neurons in the first layer, then the number of neurons in the second layer, then the number of neurons in the third layer, so on and so forth, right? So if I want to store the amount of information that is required in order to recreate this so-called network, maybe I'll need to store some 10, 15 different values, right? If I store these 10, 15 different values, maybe with the help of that I can recreate this so-called network. So now let us go back to the large language model. So when I say that the large here may refer to, the first thing is the model size. So now the network that we are trying to recreate, okay, the number of parameters or the number of weights that are required in order to replicate this is no longer 10, 15, 20. Okay, we are talking about millions or even billions of parameters, right? So just imagine that if you want to store 1 billion floating point numbers, right? The and assuming that each floating point number is being used, it is being stored in 4 bytes, right? So 4 into 1 billion, this is the number of bytes that are required in order to store a model which has, let us say, 1 billion parameters. So whenever I say a large language model, this is one of the things that you would see, that if you want to download such a model, for instance, or you want to execute such a model, the amount of memory that this so-called model file, for example, requires would possibly run into GBs, right? You might require GBs of space in order to store that much amount of information. The second thing where usually the large actually the large term is going to impact is the amount of training data that was used possibly for creating this model, right? Now I think all of you possibly know that when OpenAI launched the first version of ChatGPT, it was met with a mixed reaction, right? Some people were simply very dismissive of ChatGPT. They thought, oh no, nothing like ChatGPT is actually going to work. No model can ever have so much of knowledge about natural languages. Natural languages are very hard. You have ambiguities, you have cultural aspects to it, and thus it is not really possible for just one particular machine learning model to be able to learn all this, right? But then I'm pretty sure that at least today, right, when people use chat gpt, those apprehensions are gone. Yes, there are newer problems. Many a times chat gpt might give you answers which are possibly factually wrong, or it might give you answers which are only partially correct. But you understand that if we start comparing the knowledge of ChatGPT to any average or even a smart or high IQ human being, I'm pretty sure ChatGPT would possibly beat the human being hands down in most cases, I would say, right? So and how was this made possible? It was made possible because these modern day large language models, they take up their training data from a source which is absolutely what can I say, it's full of chaos. It's a place that is full of chaos, and that place is called the internet, right? So on the internet, anyone can put anything. You can put facts, you can put fiction, you can put correct reports, you can put factually incorrect things. All these things are there on the internet. So typically when these so-called large language models are created, you take up data mostly from the internet. Right now it depends on how much computational resources you have, but based on that you decide how much of the internet are you going to use for the training data. But even in the most simplest cases, when we are talking about small LLMs, right, the amount of training data could be, let us say, a billion PDF documents or a billion Word documents. We are talking in that range, right? So that is another aspect of large that is coming in here. The third aspect is the size of the vocabulary. So if you remember this particular picture, I said that in the simplest case, I use a language model to just predict the next word if I tell the language model what were the previous few tokens, right? Now, and I told you that the way in which this language model actually performs the predictions is that it essentially assigns some probability to each token. I repeat, each token in this whole vocabulary, right? So this is going to be a huge vocabulary if we are talking about English, right? So typically whenever we talk about large language models, the vocabulary is also essentially run into billions, right? There could be billions of words in that so-called vocabulary, and this large language model has this almost impossible but yet it is possible task of assigning some probability values to all of these so-called tokens in the vocabulary. And it is because of all these things that a language model essentially becomes large, right? So whomsoever asked the question, I hope your question is answered, or if you want we can have some more discussions over it.
Is there any minimum sample size should follow for this category, sir? First question from my side.
um, Minimum sample size as in like for training, are you trying I mean sample size as in
For
what?
yeah, for training the data.
Okay, so now the question is, it's a very logical and practical question, right? So let me
Yeah,
answer
the
it
thing
also.
is, yeah, can I speak now? And the
Yeah, sure.
thing is, when we go for implementing all those models in AI thing,
Mm-hmm. Mm-hmm.
we need to produce some accuracy and all those parameters, right?
Mm-hmm. Mm-hmm.
Hyperparameter or
Yeah.
multi-parameters.
Yes.
For that, some categories there to choose the sample size, because if I have when I come to medical data, we have less samples and less data, so
Mm-hmm.
we are facing some difficulties in producing particular reach of accuracy or whatever it is.
Mm-hmm.
So I have doubt in that whether we need for training minimum samples of like some people said you need 1,000 samples like that.
Mm-hmm.
So
Mm-hmm.
based on that, I have doubt whether is there any minimal category we have to follow for whether for splitting is as training and testing.
Okay. So first of all, let me try to understand I'll just rephrase your question. If I have misunderstood it, you can correct me. So from what I understand, you're trying to say that if I want my own data to be, let us say, used for producing a large language model, what is the typical size of training set that I need, right? Let us say for starters, if is this what you, let us say if I want to produce an LLM for the usage in medical domain, what is the bare minimum number of documents, for example, that I need in order to start off? Is this what you're trying to question?
Yes, sir. Yes, sir.
Okay, okay.
Yes.
So very nice question, and let me tell you the answer as well as what people do in such cases. So typically, these so-called large language models, no, um, I'll tell you a little history. Maybe that will give you some context. Okay, the large language models were never really meant to do what they are doing today. Okay, today they have become our personal assistants. Right, they help us with so many things. But the initial, the initial push was not really to produce these intelligent agents that have a lot of knowledge, right? The initial intention was just to create a simple model that can understand some particular natural language, for example English, right? So the objective was not really to produce a chat GPT that can diagnose my illness based on my symptoms. It was not the original intention. The original intention was, can I produce, let us say, a language model which can chat with a human being as if two teenagers are chatting with each other, right? It was not really meant to be knowledgeable. It was only meant to be a model that understands the language. However, when people started training this with lots and lots of data, and this data came from different domains, you understand, internet is full of material from different domains. They realized that in fact there is a specific uh, feature called self attention. We are not going to go into self attention; it's a part of deep learning field. But they realized that uh, these so-called language models were implicitly also gaining knowledge. Even though our objective was to teach them English, not only did we teach them English, we also gave them some knowledge about the world, right? So this was in the beginning, this was purely accidental. Okay, the objective was not really to make them smart agents. The objective was just to make them agents of, let us say, English language. But then people realize, oh, okay, this so-called mechanism that we have been using to train them with large amount of data, it can also impart, or these models, these large models which are having billions of parameters, they have the ability to even store knowledge and not just the, let us say, grammar of English language. So typically, coming back to the question that you asked, usually the large language models were not really meant to be trained over, for example, medical data, or for, let us say, legal terminology. The large language models initially were meant to be just, let us say, an English speaker or a Hindi speaker, something like this. The knowledge part was imparted as an implicit thing. Now, coming back to your point, that let's say if you want to start building a new large language model, how much data do you require? Now, unfortunately, the amount of parameters that we have, right? Let us say billions of parameters, that usually decides how much initial data you need, right? But a few thousand per documents are always going to be too little, right? So in most cases, you will probably not be able to come up with a new large language model with just a few thousand documents. However, as I told you, since people realized that these so-called LLMs have the capacity to also store knowledge, they are not just English speakers. They can understand medical science, they can understand legal terminology. So there is a concept of fine tuning an LLM. Okay, so what does fine tuning an LLM essentially means? It means that maybe the initial LLM was built with 1 billion documents, right? And this 1 billion documents has given it the capacity to have a conversation with another human being, right? And maybe some basic understanding of all the fields in the world. But let's say if I want to make it an expert of medical terminology, because maybe when I crawled the internet for documents, maybe there were certain very specific medical terminology that was not a part of the training set. So if I ask this so-called LLM about a particular disease, for example, maybe it doesn't know what that disease is. So there is this concept of fine tuning an LLM. So there are a number of LLMs which are currently available online. There is a very popular website called Hugging Face. Um, what typically people do is that they pick up one particular core LLM, and then over that, even a few hundred documents are possibly enough to impart just that additional layer of knowledge. Okay, just some, it does already know how to speak English. Okay, probably it doesn't know what is cholera, probably it doesn't know what is polio, right? So maybe a few hundred documents about cholera and polio are then fed into this so-called LLM, and then after fine tuning it, not only can it actually talk in English, it also knows a little bit more about the diseases. So today, if you want to use a large language model for a specific domain, and there are these LLMs which are already available. Okay, people have fine-tuned LLMs for legal domain, for medical purpose, for sports, for share market. There are LLMs which are available out there. In fact, Bloomberg, one of the it's a huge multinational firm. I think they call their own LLM as Bloomberg GPT, right? And the job of this so-called GPT is to provide you share advices or investment advices. Okay, it's a paid service, not everyone can use it, but if you are one of their Bloomberg subscribers, you get access to Bloomberg GPT. It gives you investment advices, right? Something that possibly Chat GPT may not be able to do, because Bloomberg has fine-tuned certain open source large language models, and they have come up with Bloomberg GPT. So this is the crux of what we started off. This is the discussion that we started off. Anything else that you would want me to elaborate upon, or any other queries or discussions?
Uh, yes, sir. This thing is cleared. So, if I am dealing with some image samples,
Hmm.
so can I, for example, if the diagnosis report has been produced by doctors,
Hmm.
so that thing will be in English token, whatever you
Yes.
mentioned, English tokens.
Yes.
So, whether it is possible to do that report automatically through LLM?
Yes. So basically, as I told you, that the path you will have to look upon is that, first of all, you will have to find out some open source LLM. As I said, Hugging Face is one place where you can look for them. Keep this in mind that these so-called open source LLMs, they come in wide varieties and shape. Right? When I say wide varieties and shape, it means that there are small LLMs also that you can possibly run on your laptop, and then there are very large LLMs for which you might require a good sized GPU server, right? So you will have to pick a particular LLM based on how much hardware resources you are having with you, right? If it, and keep another thing that you have to keep it in mind is that fine tuning an LLM is almost always impossible on a desktop class machine, right? You will almost always require a GPU server, for example. So typically that is costly, right? I mean, even a very small, let's say low-end GPU server will possibly be somewhere between 6 to 8 lakhs, right? So the amount of money that is required to build up such resources is very huge. So this is a very common reason that people are not able to build their own LLMs, because the price is prohibitive. But provided that you have enough infrastructure, you have enough resources, the path is like this: you pick up some open source LLM, you have whatever data you have, let us say a few hundred documents or a few thousand documents, and then there are codes. There are very small Python codes, possibly 10 to 20 or 30 lines of code. For each LLM, you can find this code available on the internet about how to fine tune a particular LLM, and you execute that code on a good quality server, and then what you get is a fine tuned LLM. But as I said, it's easier said than done, because in most cases the prohibition is not really the availability. There are open source LLMs which are available, and the code to fine tune them is also available. The thing that actually stops people is the amount of resources that are required in order to fine tune them, right? So this is the problem, that if you want to do whatever you ask, it is perfectly possible, it is doable. The issue is
So,
with resources.
so in this case, sir, how much data I have to deal? Because if I go with both image and text,
Hmm.
for example, I will be going with the image and along with the text report. So
Hmm.
if I go with because in if I having around 200 people's images and 200 people reports from doctors, is
Hmm.
it possible to run and produce whatever the parameters accuracies? Is it
Okay.
possible with this
Okay.
sample
Okay.
size?
Okay. So let me first pull you back a little, because uh, one of the problems here is that even though our modern GPTs like Chat GPT, Gemini, they might give everyone a perception that images can be simply consumed by a particular LLM. At the core, an LLM only works with text. It doesn't have the ability to process images, right? So if you want to do any kind of fine tuning, it can only be done over text, right? So images, there are other pipelines. Okay, again, this is beyond our today's discussion, but essentially the images are supposed to be converted into a specific form, which can then be fed to LLM, right? I particularly do not work in this particular field. I am not an image processing guy, but there are ways in which images are consumed in LLMs. Not particularly medical images as such. I'm not exactly aware what techniques the medical domain people use in order to convert their images into something tangible. But let's say a simple image, the LLM will basically perform an OCR over it, right? It will just do an optical character recognition, try to find what text it has, and then use it. But let us say in case of an X-ray image, right, or in the case of an MRI, I particularly do not have any direct knowledge as to, maybe you can talk to some people who work in the field of image processing. They'll possibly be able to tell you how this is done. Usually what we do is, like, one particular example that I know is, people prepare some kind of histograms, right? You, for example, you might convert your a whole image into a pixel by pixel description, that the first pixel looks like this, the second pixel, and when I say description, as in the color that that particular pixel has, right? It's going to be a large amount of data, but that is one way in which it could be fed into an LLM. But as I said, I'm not an expert of the image processing domain, so image part is going to be a completely different challenge, how to feed image data to an LLM. Typically, an LLMs are not really meant, because they are language models. Okay, they are supposed to work over text. But as I told you, this implicit knowledge that they are gaining, right, while training, the modern day GPTs like Chat GPT and Gemini, they also provide you inferencing over images. But for that, you will have to possibly discuss things with an image processing expert. Okay.
Okay, sir. Thank you. Thank you, sir. Thank you for your time.
Thank you. So let's move on. We'll just go to the next part. So till now, what exactly we have discussed? We have discussed that what exactly does a large language model look like, and I told you that one of the most basic things that the LLM does is that it predicts what is going to be the next word, right? And how does it do that? It simply assigns some probabilities to every word, every token in the vocabulary, and with the help of that, I just say the most possible token is basically the token with the highest probability. But then you understand that what it would do is it would essentially create a kind of a fixed output, right? So if you give me a specific set of input, a precise input, the output will also be exactly the same, right? Because if I am picking the most probable word every time, the input and outputs will not change because the probabilities are going to be same. So this is where people came up with the concept of temperature, right? So this so-called temperature is essentially a kind of a hyper parameter. It's a parameter that can be tuned separately from the large language model. And this so-called temperature adds some kind of randomness to the language model's output, right? Now the question is, why do I need randomness, right? Because this is how human beings actually behave, right? If you ask me to give this lecture all over again, let us say tomorrow, right, the the set of words that I will be using today may not be exactly the same as the set of the words that I would use tomorrow, right? This is human behavior. Even if I want to say the same thing two times, maybe I will not simply repeat everything verbatim, right? Maybe there will be some words here and there which will change. So in order to make these so-called LLMs look more humanly, right? Humanly as in something which is not a robotic output, right? People added something called as a temperature, right? In this so-called LLM, and this temperature is essentially a value which is a small floating point number. If the value is 0, it essentially means that my LLM is completely deterministic. Deterministic as in it always chooses the most likely word as the next word prediction, right? Now, if you keep increasing this temperature, what it will do is it will start picking some random word. So if I say instead of picking the most probable word, pick any word out of the top 5 or out of the top 10. Okay, pick a random word out of the top 5 or top 10. So if I go back to this example, maybe instead of mat, I could have picked rat also, right? So maybe first time I ran this language model with this input, the output was the cat sat on the mat. Maybe in the second iteration it might say the cat sat on the rat, right? So there is some kind of randomness to the output. So this so-called randomness, as you understand, it is possibly not required in each case, but in order to make things a little more humanly, right, this temperature, when fine tuned to a good number, it makes you look like you are actually talking to a human being and not some robot, right? So typically there are some values here. Let us say 0.2 to 0.5 is the conservative or focused, very predictable, safe choices. You don't predict a word that is quite random. Point up to point 0.7, we can call them something around balanced, okay, a mix of something sensible and something creative, right? You might come up with some outputs which might seem a little creative, right? They are not the ordinary outputs. They look a little more flashy. And the moment you go beyond one, right, you are now moving into a very risky domain, right? And this is where you might see some output which might not make any sense, right? Or it might be output which is too difficult to comprehend, right? So let me give you an example. GPT-2 is one of the most primitive large language models that were trained in the beginning, right? It was trained with around 117 million parameters and with only about 8 million text documents, right? It's a very small large language model. And if you execute GPT-2, I executed GPT-2, and by the way, um, uh, all of you can access the contents that I'll just show it to you when we go to our first code example. So all the slides and the code examples for this particular session are available online. I'll just share the link with you, and you can download them, right? So I will also show you this example live, in a little while. But basically what I did was I just executed GPT-2. I asked it to predict the next word, and this so-called next word prediction can be done in a chain, right? When I say in a chain, as in, let us say I first gave it this particular input once upon a time, and then I asked, okay, now generate some output, right? And then this is what it said. Let us say it said, the next word is the, right? Then I say, okay, now generate the next token with the input once upon a time, the. So then the output is word, right? So in the next iteration I would say once upon a time the word. Now it said was. So this can be done in a chain. So whatever the LLM has already predicted, it gets appended to its input in the next invocation, and then we, in this way, we actually make an LLM a word generator. It will keep on generating words one after the other. So I simply executed GPT-2 with some different temperature settings, and this is what happened when I ran it 3 different times, and you can see with a very low temperature, the output was exactly the same in all 3 executions. The output was exactly the same. I increased the temperature a little bit, and then you can see that there is small changes now seen, right? The world was up to this point, I think it was quite common, and then here it became filled, right? Here it still remained the same, a place of great beauty and peace, right? And here it said and great danger. So there are small variations now. The moment you execute these GPTs different times, there would be small variations in the output. With point 7, now things will start changing a lot, right? So once upon a time, I was sitting in my office. Once upon a time, the world's governments were able to achieve. Once upon a time, I thought to myself, right? So you can see what is happening here, right? With point 7, they are taking very different paths. Okay, different executions are producing very different texts. And with 1, now things will be quite wide, right? The emperor's men were fighting with some of their own men. He thought of the great and magnificent man and the great man that was with, right? I know, once upon a time of great fear, the heart had been struck with. So it's completely nonsense, you can see, right? So what exactly is happening? It is the same LLM, but what I am changing every time is the temperature. And with the temperature, and you can call this the seed as in this is the initial text that I have given it to it, and now I am asking it to predict the next token, and based on this, it is going to predict the next to next token, so on and so forth, right? So this is an example of how GPT-2 was. Now let me show you an example. I'll just run some code. Before that, let me just share my screen. Where is it? Here. So I hope you guys can see my terminal screen as of now. I'll just make it a little more bigger, right? So this is my terminal screen. I'm currently in Linux. By the way, if you want to open up these resources, you can find it at this location. Okay, it is https tinyurl.com/iitgedp. So if you go to this link, you will be able to see the resources that are available for this particular session. You can go and directly check out these things. So I hope everyone has written this down. It's just tinyurl.com and then /iitg-edp. So all these code examples as well as these slides are already available at this particular URL. You can just go there and open it, and you will get access to it. Okay, so this code is already available to you. You don't have to copy anything or write anything down. This is already available to
Hello,
you.
sir.
So
Hello, sir.
if you want to run this code,
Excuse me,
there
sir.
is this file called requirements.txt. I hope you guys are already aware of something called pip. Let me just show you an example of how pip works. All of you are aware of how to use pip, because we've gone, I think you have gone through multiple just a minute. You've gone through multiple sessions before. All of you are aware of pip?
Excuse me, sir.
Anyone?
So can you share the link in chat box?
No?
The resource
Okay,
link
anyhow.
in chat box?
Are you guys aware of
Oh,
something known as a virtual
sir, am I
environment?
audible?
Are people actually replying in the chat? I could not see the chat.
Sir, am I audible?
Yes, you are audible.
Okay, so there is a query from one participant, Anurag Verma. So
Yes, yes.
he's
Just,
asking you to post the link in the chat
oh
box.
yes, just a minute. I'll just put it here. Okay. HTTPS. It's there. So I hope now it's visible to everyone, right? Okay. So I hope all of you can open up this. In fact, let me just check it's working, right? Yeah. So currently it's only session 1, but there will be session 2 things as well here. The link to the link to the the slides are also here already, and then I would want you to look at the folder called GPT-2, right? So currently I am inside the GPT-2 part. Okay, so I hope you guys are already aware of the concept of Python virtual environment. So I have already created these virtual environments here, right? This is my virtual environment. Okay, but if you want to install these things, if you want to set up your own virtual environment in order to execute these so-called coding examples, the requirements that are required, the packages that are there in this requirements.txt file, right? So the actual code will be pip minus r. I'll just put it in the chat, just a minute. So for each of these examples that I will be sharing today, just use this command, pip install minus r requirements.txt, right? So um, for every environment that you want to set up, for example, for GPT-2, for BERT, for sentence transformer, the requirements are already mentioned in the requirements.txt file in the specific folder. So with the help of this command, you can simply install it, right? So I already have the things installed. I have a virtual environment which is here. So I will just activate that so-called virtual environment. I just want to understand whether everyone is aware of the concept of a virtual environment. Can anyone just say that you are aware or not? Because it's already day 9. I'm pretty sure somebody would have covered it. Is anyone replying in the chats? Nobody. Uh, right. So I'm assuming that you are not aware of it. So essentially, Python provides you this opportunity to create a virtual environment. A virtual environment is essentially a kind of an environment where you install all your dependencies, but you don't disturb the global installation of Python, because many a times you might want a specific version of a specific package, and let us say for another use case you want virtual environment for yourself. Yes, what I'm currently doing is I have just activated the GPT-2 virtual environment in my terminal, right? So now this particular environment has all the things required in order to execute my GPT-2 example, right? And basically these are the packages that I have already installed, right? So if with the help of this, you
Sir,
can.
I think your screen sharing has been mistakenly turned off.
Oh, really sorry, and thank you for telling me. Mm, I hope it's visible now.
Yes, sir.
Thank you. So right. So Okay, somebody replied. So I'm just trying to understand, are you guys aware of the concept of a virtual environment? Because nobody is answering, I'm expecting no. Is it?
No, sir, no idea.
Okay, so maybe I'll just okay, what I can do is let me just go to a temporary folder first, right? I'll just create a new virtual environment for you here, right? So the way to do this is with the help of Python. You can create this. It's called the virtual environment variable, right? And then you can give it some name, right? I'm calling it the test env. I'll just put this, copy paste it into the chat. Just a minute. This is the the command that I have just executed, right? Now, in order to activate this, you just need to execute a particular script which is there inside the bin folder, this. So the moment I activate this, now you can see that it has been changed to the test env, right? Now if you want to install anything that is required, you can just do pip install and -r, and let us say the requirements.txt. If I give it that that same requirements file, it will start downloading those packages from the internet and install it in this particular test environment only. It will not be installed anywhere else on my machine, right? So this is the advantage of using these so-called virtual environments. You keep everything clean, right? So for example, I have 5 or 6 different virtual environments created for this particular session, for this particular day, so that I can keep the packages associated with each of these examples separate from each other. So let us go back to what we were doing. I'll just reactivate my GPT-2 virtual environment. Okay, so now you can see it is GPT-2 here, and so here I have a simple, very short Python file, right? I hope it is visible to everyone, right? And if the font is not good enough, I can increase it further. But I hope this is big enough for everyone to see, right? So what exactly is happening here? We have some packages that are being used here. For example, I understand that because you have gone through the basics, you understand what this so-called line means. We are doing some importing of certain useful utilities that we want. We will talk about what these utilities look like in a little while, but first I just wanted to, in order to just bring your attention, right? So you can see what exactly is happening. I'm giving it a small prompt, once upon a time, and then I'm asking my GPT-2 to generate certain tokens in a loop, right? The number of tokens I want, right? And then this is what is going to happen. Let me first execute it. Let us first see the output, and then we will talk about what the code is doing. Okay, so it says that for the temperature 0.1, this is the output. Once upon a time, the world was filled with people who were not afraid to speak their minds, right? The first thing that came out of my mouth when I heard this story is how much it changed me and what kind of. Okay, imagine that this is one of the most primitive LLMs that were ever created, right? It only had I think 100 million parameters or so, and I think a few million documents. We are not yet in the billion scale, right? But let me run this same code all over again. Okay, now let us try to compare the point one, the output for point one, right? The people who were not very good at what they. Okay, so typically this, in this particular case, our GPT-2 is even doing things with 0.1. I should have possibly given it 0.01. Let us start with 0.01. That would be much easier. Okay, this is a very, it's a very small number. I can't give it 0, by the way, right? Because most of these models do not accept an exact 0. You can give a very small value which is almost equal to 0, but not exactly 0, right? So let me run this all over again. So now you see the difference between these two invocations. This is pretty much the same. These two. Okay. So the thing I'm trying to show you is the smaller is the value of temperature, the more predictable is my output going to be, right? I think it's almost exactly the same. This one and this one, right? And as you keep on increasing the temperature, you would start seeing a pattern of randomness, right? So let us see for the pattern 1, this was in the first invocation and this was in the second invocation. Okay, so this is the idea of temperature. And what exactly, now let us go back to the code. Okay, so basically we are doing something called tokenization. We will talk about what tokenization and vectorization is right after this particular example. But for now, just assume that essentially what is it that we are going to do? We are going to convert our text into some number, and these are the so-called temperature values. I am setting the temperature values here, right? And this is, as I said, it's more like a hyper tuning. It's like a knob. Consider this pretty similar to a knob, right? So a typical model has multiple knobs, and this is a knob that you can tweak in order to make the output more random, right? So in the first case, I'm just keeping it to a value which is very close. Output will be predictable, what it is predicting, and the moment I keep on increasing it, it will become more and more random, right? And so this is just to give you an example of how GPT-2 can be used. Today what you can do after installing the particular requirements, just change this so-called prompt, right? I started off with once upon a time. Just give it some other seed. I mean, maybe we can try it with something else, right? What else? This or there was a, let us call it just there was a, right? And then execute it. So this is the first one. There was a lot of talk about the possibility that we could have an expansion in this area. There was a lot of talk about, so you can see till what point it is the same. I think about the possibility here. You can see there is a difference in the next word predicted at this point of time. Okay, here it predicted V, here it predicted there, and the moment there is one change in the predicted word, the chain changes, right? From here onward, the chain will be different, right? For different outputs, the chain would probably start to get different. So this is could after V, and here it is would after there, right? So once there is a simple change, things are going to change. In this particular case, you can say lot of, it changes here, right? Up to here, things were same, but now in point 7, the predicted word is excitement, right? And here it is right at the start. Okay, it did not even take up lot of. With temperature 1, the first predicted word itself is big, right? So many things are there. Keep in mind that GPT-2 was very basic. Okay, it is nothing compared to the kind of LLMs we have today. Okay, it's a very basic, very primitive LLM. The only advantage of it is that you can possibly run this on your own laptops. Okay, you don't need fancy amount of hardware in order to run GPT-2. But as you might see, it's a very limited, it's a very simple model. And if you ask it to generate a story, for example, at some point of time it will start producing rubbish. That's the problem, right? So this was about GPT-2, a very basic introduction to GPT-2. Now we have not yet discussed how GPT-2 was able to do this, right? So here we are going to go back to our presentation and let us continue with some other fundamental topics, and then we will see some more code. I hope everybody is able to access that folder that I have shared on OneDrive. If anyone is still facing problem, please let me know. Right. So we were here, right, and we were talking about GPT. This part is done. So, but then let us take a small detour, right, because I did not really explain conceptually how exactly was GPT-2 able to produce these so-called tokens, right? We did not discuss it. We just saw a playground, right? It was just an LLM in kind of a in a box. We did not really talk about much, right? So how exactly does a typical LLM work? So let us have a look at it. So there is a simple chain that works like this, right? And let us talk what this chain looks like. So the first part of the chain is what we are calling as the user text prompt, right? Now, if you understand, in our case, we were giving it once upon a time, or there was something like this, right? So it begins from this, or the modern LLMs, because they are let us say much more capable than just predicting the next word. Today our LLMs receive complete queries, right? You can write your complete query, and then and this is, by the way, something that you need to understand. What exactly is the LLM doing? At the core, it is just trying to follow up your question with the next token, right? So let us say if the query was where is Taj Mahal, question mark, right? Now, in this continuation, just imagine that somebody has written this text in continuation in some place. So the next possible sentence will be, the Taj Mahal is in Agra. So the job of the LLM is to first predict the, then the next word will be Taj, then the next word will be Mahal, then the next word will be is, so on and so forth. And that is what you possibly see whenever you interact with Chat GPT or Gemini, right? You typically don't see the complete text being pasted as a response in one go. You would see that the words appear one after the other. I mean, sometimes they might be too fast for you to register. Okay, you might seem that it has pasted a complete paragraph in one go, but essentially what is happening, if you run these things on a slow internet, you would possibly see that essentially whenever you interact with an LLM, they produce one word, one token at a time, right? So what exactly are they trying to do? They are just trying to do text completion. Whatever you have given to them as the prompt, uh, their job is to produce the next token, right? That is the idea, right? And then the LLM creator, right, just like we created a small Python script, the LLM creator simply starts feeding it its own output in a feedback loop. So now after the, it produces is, after is it produces Taj, after Taj it produces Mahal, so on and so forth. So let us just summarize what exactly is happening here. So essentially, the first step is that the user provides some kind of a question, a sentence, or even a paragraph to start with, right? And this is where the things begin. The next step is something that you might have seen as possibly the first or second statement of that script. It's called tokenization. So what exactly is tokenization? um, I told you that the LLM has a vocabulary with it, right? And I told you this vocabulary might have billions of tokens in it, billions of words in it, right? But the question is, typically computers are not really that efficient when it comes to dealing with strings, right? In almost all mathematical computations that you would read, there will be no strings. They are just numbers, right? You pass a mathematical function works over numbers. It doesn't work over A, B, C, D. So in tokenization, what we do is, whatever text we are going to work with, we just break it down into smaller chunks and we call them tokens, right? The tokens, in the most naive way, can be considered as words, right? So for example, in this particular text, things begin with an input from the user, right? So here things begin input from, all these are tokens, right? Of course, modern LLMs, they have gone to the level of sub word tokenization, right? So maybe you will not only just create one token from playing, you will create two different tokens which look something like this. And by the way, this is the reason that modern day LLMs are so good even if you make spelling mistakes. Why? Because these tokens have been created at the sub word level. So even if you make one or two characters as a mistake, they are very quickly able to recover from it, because the overall number of tokens, it doesn't make much of a difference, right? So each token is then mapped to a, let us say, a unique integer, right? We give them all a unique number. Let us say token number, the first token is given the number 1, the second token is given the number 2, so on and so forth, right? Every unique token gets a unique ID. Then this is basically the heart of a typical LLM, called vectorization. So what exactly happens in vectorization? Each token is then mapped to a very dense vector. So what exactly is a vector? Going back to basic mathematics, a vector can be considered as a collection of some real numbers, right? Let us say if a vector has 5 different numbers, it means that these numbers are, let us say, separated by a comma. I write them like I, comma j, comma k, and so on and so forth, right? So now what I'm saying is that each token that I have is going to be mapped to a dense vector, right? So it's a dense vector, as in it's going to have a very large dimension. We are not talking about just 3 numbers or 4 numbers. We are talking about hundreds of numbers or even thousands of numbers, right? So each particular word or each particular token is going to have a vector, let us say, which is n dimensional, where n could be 500, 1000, something like this, right? So transformers, this type of architecture of deep learning networks, they work very well when you convert your inputs into these so-called vectors, right? They are essentially just a collection of numbers, and then these so-called transform, again, this is beyond our beyond the scope of this current session. This is something that you will probably be taught in a typical course on deep learning, that what exactly are so-called transformers. And but at the very basic, you can understand that these transformers are a very specific type of a deep learning network, right? It's a very peculiar type of a deep learning network, and they excel at working with these large dimensional vectors, right? So these so-called transformer vectors are essentially going to do some of their own thing, right? Essentially they are going to output something out of it. And what exactly is it that they are going to output? They are going to output probabilities for each and every token in the vocabulary, right? So if there are a billion tokens, we are basically looking at a billion probabilities. And based on the actual temperature setting, you might pick what will be the next predicted token, right? It could be the most probable token, it could be the second most probable token, it could be the 10th most probable token, so on and so forth. But just trying to understand the the larger picture, what exactly is happening? Very good large language models, they come up with these probabilities for the next tokens. And typically the top 50 or top 100 tokens are all good tokens to start off with, right? Instead of saying the Taj Mahal is in Agra, you could have also phrased it as Agra is where the Taj Mahal lies, right? So the first token could be the, or the first token could be Agra, right? But this is where the LLMs excel, the modern day LLM. Based on what was the previous tokens, it decides what is going to be the next token. And if the temperature settings are in the moderate region, usually 0.1 to 0.2, this is the most common temperature setting for most LLMs, 0.1, 0.2, in that range, uh, then the output will be something that makes sense. And if the LLM actually has knowledge about this particular field, this particular question, you are also possibly going to see a good answer to it. So while going through the details of all of these are possibly going to be out of the scope for this session, we will discuss the most important part in a little more detail, right? The vectorization aspect. So what exactly is this vectorization? How do you convert a simple string to an array of integers, right? The concept of vectorization is something like this. Based on lots and lots of data, there are certain libraries. I mean, the most common one, the first one that came out was called Word2Vec, but today Word2Vec is considered a little old for usage. Modern the modern GPTs possibly require much more than Word2Vec, but the concept is simple. Word2Vec, or let us say sentence2Vec, the idea is you are talking about some kind of an n-dimensional space. Here I have only shown 3 dimensions, but think about an n-dimensional space, and each and every word or each or every sentence essentially maps to a point in this so-called n-dimensional space. Now, those transformer, deep neural networks that I told you, one of the best things that the transformers do is that they produce a set of weights in the neural network, so that if you give a particular input, let us say you give me the input, can you help me? This is the input, and I want a vector representation. By the way, the vectors could be for a single word, it could be for a couple of words, it could be for a sentence, it could be for a paragraph, it could be basically any amount of text, right? So there are ways in which, and the size of the vectors remain exactly the same. So if the value of n is, let us say, 500, um, can will also have a 500 dimensional vector, can you will also have a 500 dimensional vector, can you help will also have a 500 dimensional vector, and can you help me will also have a 500 dimensional vector. All of these pieces of text are essentially going to give me a 500 dimensional vector. And this picture actually shows that a good vectorization strategy, what does it really do to our data, right? I hope you can already guess where this is going. So a good vectorization technique, which of course was developed, this so-called vector embedding model must have been developed after training it over large amounts of data. So after doing this training, what it is able to do is, if I give you certain pieces of text whose meanings are semantically closer to each other, in this so-called n-dimensional space, their vectors are also quite close to each other, right? So for example, hi there, good morning, hello, they might all be very near to each other, as compared to it's raining. Any questions?
Hello, dear
Yes.
participants, all are requested to please mute your mic, okay, when the session is going on. Thank you. Over to you, sir.
Okay. So as compared to let us say a sentence like it's raining, it's very cold today, the sun is shining. So you can see these fragments of text are essentially talking about weather, and then these fragments of text are talking about some greetings, and then these fragments of text are essentially some questions, right, that you are asking. So a good vectorization technique, and where exactly are you going to get these techniques? These are known as vector embeddings. The most popular vector embeddings that are available today are by Google. It's called BERT, right? BERT embeddings, and we will have a look at BERT embeddings as a code example soon enough. But this is the, and you understand how exactly are these so-called deep learning models able to do this? They are able to do this because they were trained over very large amounts of data, right? So essentially, over a period of time, they see that mostly all the emails start with something like this: hi there, good morning, hello. So the appear seems to be exactly the same, right, or very close to each other. So this affects their vector embeddings, right? So their vector embeddings are very close to each other. Similarly, these terms may actually appear quite clear, quite every time people are going to talk about weather, they are essentially talking about these words. So these vectors are essentially being created out of that particular knowledge base. Similarly for this, right? So this concept of creating a vector out of a string is the most basic and yet the most important requirement of any large language model. Without this basic assumption that I have this ability to be able to transform certain text into an array, without this basic ability, large language models would not have been possible. So now you understand that thing you need is some kind of an embedding model, right? Without an embedding model, a large language model is pretty much nothing, right? So now what we are going to do is we are going to look at two common examples of these vectorization embedding models. The first one is called BERT. The second one is called sentence transformer. Both these are heavily used today. I would say sentence transformer is more, possibly a little more popular because it's more lightweight and it has shown very good accuracies with text. But BERT is also very popular. In fact, still a lot of people use BERT in their own projects. Both of them are freely available. You can use them if you want, whenever you want. And so let us just stop here and then move into the code window.
Excuse me, sir.
Yes.
Sir, we don't have the access for that link to open.
That link is accessible without any login. You can see, just try this. Open a incognito window. Sometimes if you are already logged into some Microsoft account, it might actually stop you from accessing it. Just open an incognito window and
Okay.
then
Okay.
paste it there.
Okay.
Right? Just try it. You should be able to open it. Okay.
Okay.
Has anyone been able to open it? I mean, uh, can anyone confirm if they've
Yes,
been
sir.
able
I've
to?
tried it and it worked.
Right. So it's essentially it should open without any logging in. But if you're already logged into some maybe your own personal um, Microsoft account or a work Microsoft account, you might be debarred. So please open it in an incognito window. It should work. Okay. So let us now go back to my terminal. I hope my terminal is again visible now.
So,
Yes, sir.
Those of you who have already opened up, so those of you who have already opened up the link, you can see that the next examples are in BERT. Okay, the folder BERT. I already have a particular virtual environment created for it, but you can create it whenever you want. Again, the way will be exactly the same. There is this file here. Right, so these are the things you need. Only these two things are required to run the BERT example. So you can use the pip in order to install them. And then I'll just activate this. Right, so now I'm in the BERT environment. So let us see what I have with BERT. I have two examples related to BERT here. Let us first see the embedding example, because this is the most common use case in which BERT is used. So let me give you a, in a nutshell, what exactly we are doing here, right? I gave you the example of some text, right? I said that a good vector embedding model will be able to understand the semantics of that particular language, right? Okay, we are not talking about syntax. We are talking about semantics, right? I told you that words or phrases which have meaning that are closer to each other might actually appear closer to each other. That is the idea. Or this closure is not just it essentially means that the relationship between two words, right, this is of very high importance, right? So essentially what is it that we are going to look at here is there are four words: bull, cow, queen, and king. Okay, there are four words here, and you can see how do these words relate to each other in the real world. Essentially, bull is to cow what king to queen, right? Just imagine that I have a particular use case where I want to give you the antonym of a word, right? I want to use this so-called vector embeddings to produce the antonyms, right? And let us say I have a very small vocabulary, let us say only 50 words or say 80 words or something like this, and then I want you to tell me that out of these 80 words, assuming that the antonym of a given word already there, is 80. So then what exactly a good vector embedding supposed to do? It will essentially create two different vectors. The one vector for the word for which I'm trying to find the antonym, and then another set of vectors for all the words in my vocabulary. Now it needs to find out the relationship between any two pairs of antonyms. So let us say if I tell you that the distance between bull and cow is something like this. Now try to find out a vector which is at pretty much the same distance from queen or from king, and then you look into your space, you look into all the vectors that you have, and you say, okay, at this particular distance from king I possibly have the word queen. A good vector embedding should be able to do that. I mean, here we are doing it at a word level, so at the word level it might not work that well, but the moment you start going into phrases or sentences, these vector embeddings become more and more precise, right? So the chances that you will be able to find the similarity between two similar phrases is much higher than the similarity between two similar words, right? But still, what is it that we are going to do? We are going to create some vector embeddings here, and then we are going to check what the output is. So let me just execute this. So this is what it says. I mean, again, don't worry about the actual units, right? This is some abstract unit that we are talking about. It's possibly these units usually do not matter. What matter is the relative distances. Okay, these vectors are only going to be helpful in a relative sense. If you look at their absolute differences, it might not make much of a sense. But it says that the difference between bull and cow is 4.9. The difference between king and queen is 2.6, right? That is what it says. This is between, let us say, the specific words, right? The pairs. Now if you see that the distance of bull from cow is 4.9, but the distance of bull from queen is 5.3, right? So cow is closer to bull as compared to queen. That is the idea that we are trying to see, that if I give you bull and I say, which is more closer to this the word bull, in terms of cow and queen, you can easily say, okay, cow is more likely to be associated with bull as compared to queen. Similarly, with the help, you can also see about king, and right. So the difference between queen and king is some 2 point something, and the difference between cow and king is 3 point something. So if I give you the word king, and I tell you which of these two words is more likely to be associated with king, the likelihood of queen is much higher as compared to cow. It's a very simple example to show how vectors work and how you find differences, the distances between two vectors. But the idea of this simple example, and you can play with it, you can go inside and you can change the words. Okay, in this embedding.py you can go and play with it. You can start putting your own words, and then you can see, okay, how far is this word from this so-called word, right? And you would find some very nice things, some nice observations, right? So this is the first example related to bird. Now I have another example. So keep in mind that the job of BERT is not really to produce vector embeddings. It is essentially considered as an MLM, okay, masked language model, right? So how exactly was BERT prepared? This is how it was actually prepared, right? I would give BERT some input like this. I'm not asking it to predict the next word, okay? Usually I give it some text in this format, right? The capital of mask is Paris, right? So this is the way in which BERT was actually trained, right? This is the it was asked to predict a particular word in a sentence, right? This was the way in which initially BERT was prepared. So this is the actual use case for which BERT is good. Okay. So here, what exactly am I doing? I am giving it a particular sentence, and then I am putting a mask in this sentence, and then I am asking BERT to simply predict what token would be the most likely token at the place of this mask, right? In fact, let us just try to run this. It says France. We can also try to put some other sentence here. Let me put, what can we put? Let me call it mask was the mask ate the rat. I don't know what would be the output, to be honest, right? Extempore. Okay, it says rat. So some the rat ate the rat, right? Something went wrong, right? So I just tried it extempore. But that is the idea of BERT. It is essentially trying to predict some word here, right? Maybe this was not the best example. What else we can try? We can probably try another capital example. The capital of mask is New Delhi. Let us try this. Again, I'm not really sure what exactly it will do. I'm just running it with you. I know. So this one, it has predicted better, right? So it depends on the amount of context you are giving it. This is a very small context. If I start creating, if this whole text was much longer, its accuracies will start becoming better and better. With a very small context, sometimes it's difficult for any vectorization library to be able to predict, right? But this is another example of how BERT is used. It's pretty much like fill in the blanks, right? So this is one of the most common ways in which BERT can be used. You can use it to do what is, let us say, fill in the blanks, right? So this BERT is as I said, it was one of the first libraries that came up. It was by Google, and it was a rage when BERT came out. It was a rage. People started using it in almost everything. This was the most popular vectorization technique at that point of time, right? But over a period of time, this BERT was overtaken by a more simpler and more powerful library called the sentence transformer. This is available also on Hugging Face. And code visible to them. You can also go and check out the sentence transformer directory. I have another. These are, by the way, the requirements for sentence transformer. There are certain things you need for it, right? So I'll just switch to the sentence transformer one. Sentence transformer. Okay. So I have this Python file. Let me open up this Python file, and what exactly is it that this so-called script is doing. So here we have actually what is known as a very small knowledge base. Okay, so what exactly is a knowledge base? These are full fetched sentences. You cannot, they are complete sentences. Apples are rich in fiber and vitamin C, and they are one of the most widely cultivated fruits in the world. It is one particular factoid. You can say this is a kind of a factoid, a small fact, right? The next one is the modern car was invented in 1886 by Carl Benz and was powered by a gasoline engine, right? Similarly, the University of Bologna in Italy was founded, right? The Mount Everest located in Himalayas, the acoustic guitar. There are some 4 or 5, I think 5 different factoids. So you can consider that it's a very small, right? At this point of time, we are saying that it's a very small LLM, not just LLM, a very small intelligent agent that knows these 5 different facts, right? Now, what I would do is I would ask this so-called smart agent to tell me about some fact related to some particular field. So let me just execute it first. It says give me a sentence to compare with my knowledge, right? So you said you have seen that I had talked about we have a sentence about apple, right? So let me ask this: do you know anything about fruits? It says the closest sentence I have: apples are rich in fiber and vitamin C, and they are one of the most widely cultivated fruits. Now, you might feel that, okay, fruits, and you can see that how exactly is it that this particular guy was able to spit out this particular sentence, because there was something common here: fruits and fruits, right? And it will also say the distances of this particular query that I gave with all the sentences it had in its knowledge base are also told me, right? It says that the distance of this factoid was 0.45, for this was 1.05, 1.05, 1.06, so on and so forth. So it is quite clearly that this one was very close. Let me try it one more time without giving it fruit. Let me just say something else. Do you have knowledge about oranges? Now you can see that here I have not particularly used the word fruit, right? I mean, there's nothing mentioned about fruit, there is nothing mentioned about apples, and yet the factoid that it has brought up, okay, it says that this is the closest factoid I know, right? It doesn't know anything about oranges, but at least it knows something about apples, right? It is much closer to what I wanted, as compared to telling me about Mount Everest, right? And you can see the distances here: 0.67, 0.92, 1, 1, 1, so on and so forth. So this is the reason. So what exactly have we done? What exactly is sentence transformer doing? Let us go in here. Basically, I have these so-called so-called pieces of text, and what exactly is it that I am going to do? I am going to create some vector embeddings out of these so-called factoids, right? At the same time, whatever input you are going to give me, I will also create a vector embedding. The vector embedding must be using the same technology. It should not be the case that you use some other library for creating the vectors for this, and then you use some other library for creating a vector for this. The vector library that you use must be exactly the same. And then there is the simplest similarity is what is the cosine similarity in the vectors world. Basically, the cosine similarity is the simplest similarity. So what I do is I just find out the similarities, and then I find the distances, which is 1 minus the similarity, and based on that I simply find out which particular sentences out of all these were the closest sentence to this so called input. Okay, and based on that I print the sentence, and I also print the distances for each of the sentences that I have, right? So this, you can see that now with higher context, right, with more number of characters, you can already see how the vectorization techniques are doing, right? You would have seen that the poor Bert was not able to do well when I asked it about rat and cat, right? It did much better with capitals, but it could not do that well with rat and mat and cat and something like this, right? But here we have complete sentences, and you can see how the vectorization techniques were able to figure out that which of these sentences were the closest sentences. And now we are also, I mean, this is also a direction where which we will take up when we'll start after a short break. Maybe we'll break around after 15-20 minutes. We'll have a short break before the second session. But now where this is going, how vectorization is going to help the LLMs figuring out what is the more relevant thing to say as compared to the most irrelevant or the rubbish things that are also available in the vocabulary. It is these vectors which are going to help my LLM in coming up with more logical and more semantically perfect responses. Okay, so we will again go back to our presentation. Right, so basically now let we can understand that essentially what kind of LLMs are those that you could possibly use for your own expertise. For instance, there are two types. The first one are called as the hosted LLMs. In fact, maybe the only kind of LLMs that you might have interacted with till now are possibly what are called as hosted LLMs. So these are public LLMs. They are usually sold on a subscription basis. I think Gemini 2.5 currently is allowing some kind of free usage. Possibly, I heard for students it's free, but I don't know for how long it will be free. But the idea is that these so-called hosted LLMs are LLMs which are available for public use. Anyone can use them, and you can interact with them. And if you remember in the beginning of this presentation, there was a question about how can we feed images to our LLMs, and this is the kind of an illusion that has come into our mind because these publicly hosted LLMs, they have found ways in which they are able to process images, right, whatever way. And that is why they are proprietary products, right? They are not freely available. You can't just download Gemini 2.5 on your machine and execute, or you can't just download GPT 4.1 and run it on your service. Okay, they are proprietary products. It's not just the LLM that they have, it's a complete pipeline. We will talk about how LLM pipelines are created in the second session for today. But for now, just assume that these are sophisticated. They are not. They are actually much more than just an LLM. You have a proper system that works around an LLM, and it is because of that system you are able to feed it PDFs, Word documents, images, and it usually takes up so many things. It is possible because there is a complete ecosystem around that particular LLM, right? But otherwise, these LLMs are publicly available. You can use them on a subscription basis. So clearly, this is one option that you have at your end. Now, I also talked about if somebody is interested in having their own LLMs, right? We had discussed the possibility of building an LLM for the medical domain, right? Now, there could be many reasons why you would want to do that. For example, in medical domain, there might be patient data. This data should not be publicly shared with the rest of the world. It is possibly the property of a particular hospital or a particular individual, and sharing it with a publicly hosted LLM may be a breach of privacy. So in such cases, you can also go for what are known as in-house LLMs, right? So they can be installed on your private infrastructure, usually for the usage only within a particular organization. I gave the example of Bloomberg GPT. So you can say sorry, any question?
Hello. So, dear participants, we request you all
So
to
I gave
please
an
mute your mics. Thank you, sir.
Okay. So yeah, so I gave an example of Bloomberg GPT, right? And I told you that what Bloomberg guys did was they started off with some open source LLM, I think Llama or Mistral, and I forgot the exact LLM that they were using. And then what they did was they actually fine tuned it with some of their own data, some of their own internal documents, right? These documents might only be available within Bloomberg. There might be trade secrets of Bloomberg, right? How to do trading, what are the trading algorithms that they use, whatever it is, how do they identify a good stock. So there might be lots and lots of documents within Bloomberg which might be fed to these to these LLMs. So they did exactly the same. So they created some infrastructure within the ambit of their own organization, and then using something like Llama or something similar, they actually fine tuned their own LLM, and now it is available not only for use within the organization, it's also available outside the organization. So many educational institutes, at least in the Western world, have their own LLMs which are hosted on their own infrastructure. In India, of course, uh, because as I told you that cost is a very prohibitive factor. Typically, in order to fine tune and have a kind of an LLM, uh, bare minimum amount of infrastructure investment might range into a couple of crores, right? So uh, it's certainly out of reach for many institutes. But if you do have infrastructure for it, you can have your own in-house private infrastructure, in-house private LLMs, and both have their pros and cons, right? For in-house LLMs, you get the full control over the model, the data, and behavior. You can fine tune it as many times as you want. Um, you can restrict its the access. For example, you can say that students will only have access maybe 10 times in a week or something like this, whereas faculty might have it 100 times a week, something like this. And then you have these privacy issues. If you are within some kind of in-house LLMs, you are talking about we are talking about privacy, which you're not breaching somebody's privacy. The data remains within the ambit of your institute or your organization. The problem, of course, is, as I said, the setup effort. The cost is certainly one aspect, but the amount of effort that it requires to actually set up an LLM might be significant. For example, an institute like AIMS, they are experts in medical science. They are not really people who are IT experts. Own LLMs, it might be a significant investment, not just in infrastructure, but at the same time in IT and personnel, right? You have to hire people, competent people who can do that, right? So the setup efforts are also very high in-house LLMs, not just the cost. Another aspect of this so-called hosted LLMs is that they usually have a pay-as-you-go model, right? Towards the end of the second session today, I will be showing you the example of how you can use the OpenAI. OpenAI is essentially the parent company whose product is ChatGPT. We might not know OpenAI as a name very often, but basically OpenAI is the parent company whose product is ChatGPT. So we will use the OpenAI APIs in order to do some question answering, some custom question answering towards the end of the second session today. But and I will show you that essentially I paid them some $15 to $20 at one point of time, maybe a few months back, and they charge me on every API invocation. There is a particular cost associated with each invocation. They cut something from that balance, and this is good for a newcomer. For a newcomer, maybe you can start using LLMs or building applications over LLMs with just upfront investment of a few thousand rupees. In fact, many of we, by the way, our institute's current chatbot, IIT Dhanbad's current chatbot, is essentially using the open AI APIs, because we have decided not to put in so much of upfront investment into a simple chatbot. So in the first iteration, we are just using a hosted LLM by OpenAI, and we just use it as an on a pay as you go model. And if of course the bills go higher, we can then start to discuss it. Um, another aspect is about scalability, because you need some kind of the scaling responsibility now lies with me. What kind of a server do I need? How many users are going to come and talk to my LLM on a day-to-day basis, right? Do I have the server capacity to do that, right? Usually this so-called headache is no longer there when I have hosted LLMs. On hosted LLMs, I can simply let the LLM provider worry about these things. I don't need to care about it, right? So this is something, this is where we come to the end of the first session. So just a summary, LLMs are usually these deep learning related models. I'm calling it deep learning related because it is not necessary that you build. I mean, at least today we have all the LLMs which are deep learning models, but maybe in future, if somebody comes up with a new type of machine learning architecture, then but till then, right? I mean, which seems highly unlikely as of today. But as of today, all LLMs are essentially deep learning models we where the objective is to understand a language. And as I said, this understanding usually also come with an implicit advantage of domain or worldly knowledge, even though the idea was just to learn a particular language. Because these models go through a lot of documents, especially taken up from the internet, they also implicitly gain some knowledge out of it. LLMs rely heavily on vector embeddings. I showed you the examples of how sentence transformer was able to find out the nearest sentence to a sentence, even when um, we did not provide it any particular clue. We did not use the words like fruits or apples, and still it was able to tell me that and you can understand how that maybe the distance of um, the terms oranges and fruits, right? It would be much less as compared to, let us say, the distance of oranges from Mount Everest, or car, or something like this. So these so-called vector embeddings, in a very high dimensional space, they are the basic, they are the basis over which all the modern day LLMs are made. They provide the LLMs the crucial differentiation between two different pieces of text, right? And based on that, the LLM can take an informed decision as to what would be the next predicted token. And based on our use case, we can use LLM to generate some text, right? And I had showed an example of a story generation. And the only thing we can possibly do is play with this so-called hyperparameter called temperature. Temperature settings can help me with making my output more randomized. I would it helps me, it helps my LLM look more humanly, right? It will not provide the same output every time. It will provide some different output whenever I give it the input, right? So this is the summary of this session. In the next session, we are now going to look at three different LLM invocations. We will look at one particular hosted LLM. I have already told you that we will be looking at how to use the APIs of OpenAI for a very simple task of question and answer.
Hello. Hello, Saurabh sir. Hello.
Yes. Hello.
So when will the second session begin, sir?
Yes, so we'll take some 15 minutes break after this session, and then we'll start. Okay. So let us just take a bio break of some 15 minutes, and then we'll start. So let us just finish the first session, and any questions till now, we can have a discussion, and then we'll break for a short bio break. Any queries from anyone? No. So let us break for some 10-15 minutes, and we'll possibly join back at 12:10. Okay.
Excuse me,
Okay,
sir.
sir.
Yes, there is a question. Yes.
Sir, we are still unable to open your link you have provided.
So I'm not sure what is the problem. So what do
It
you
is asking for login, and after login, it is denying.
no?
Without login, it is not opening.
Okay, let me just try to give you the complete link. So this is actually a shortened
So,
link.
Saurabh sir,
Yes.
if you can provide us the documents which you have shared in
Yes,
the
yes.
link, then we can share it in the Google Drive link which
I
we have created specially for this
Okay,
course.
okay, ma'am. The at the link itself, you can like download. Currently, I have put the resources for session one. Let me just a minute. Give me a second. Just try to open this in a just open this link in a incognito window. The people who are not able to open it, just open it in an incognito window. Don't open it directly. It should open up. It doesn't require any logging in. And I will share the resources for both sessions simultaneously, um, with the team.
Excuse me, sir. Can I ask some question?
Yeah, sure. Please go ahead.
Sir, actually, my question is very simple here. That whatever we ask to the Chat GPT or any kind of LLM, can we rely on the information that is being created by those LLMs?
Yeah. So
Means for
now,
the authenticity for.
yes, yes. So as I said, right, for that you have to understand what is the source of that information, right? It is as if let me pose a counter question to you. When you search for something on Google, right? Let us say when you search for some answers on Google, how do you trust what you see on a particular website or not, right? It depends, isn't it? It depends on where you are seeing this, right?
Right, right.
If you're seeing this, for example, on a government website, it's very high, it's highly probable that the information is correct. If you are seeing it on Wikipedia, most likely it will be correct, but you cannot be absolutely sure, because Wikipedia can be edited by it's a community effort. People can go and edit, and there have been instances where people mischievously edit something on Wikipedia pages, and then it has to be then reverted. So it is exactly the same thing with things like ChatGPT, because these so-called LLMs were trained over internet data. You can say that there is a good chance. It depends on how do you see the internet as a whole. For me as a person, I see that internet is more helpful than harmful, right? I mean, it means that whenever I want to find an answer, usually the top results that Google give me, maybe 9 out of 10 times the answers are actually correct, right? So it is the same kind of behavior that you would see with ChatGPT. In most cases, the output would be right, but as I said, it depends on your use case. And in fact, ChatGPT per se does have this ability. It does say that, for example, if I ask, my son is having some fever and is coughing, what do you think, right? It would clearly say, see, I am not a doctor. This is how it will probably
Right,
start,
sir. Right.
right? I
Right.
am not a doctor, but based on what I know, these are some of the possibilities. He might have a viral infection, he might have asthma, so on and so forth. But go and talk to a doctor, right?
Right.
So that is exactly how we also used to work in the pre-chat GPT era, right? Typically, I would type something on Google, and then I'll, let us say, try to open up the first 3 or 4 results, and based on that I'll make up my mind. So that is exactly the same with chat GPT. I per se would say, uh, use chat gpt for non-essential cases. Usually, so you should be aware that if even if something goes wrong, there is a fallback mechanism that I will be able to deal with it. But don't blindly rely on chat gpt for critical use cases.
Right, sir. Thank you, sir. Thank you.
Okay. Any other queries?
Excuse me, sir.
Yeah, sure.
Sir, still I am unable to open that link in a cognitive mode also.
Yeah, I'm not really sure. I mean, what's really going on?
Sir,
But
Saurabh sir, in
yes,
that case, if you can share the content with us, which is there in the link, we can upload it in the Google Drive, sir,
yeah.
if
Do let
possible.
me know. Do let me know what to do. Like, how shall I share? Should I share it over email or like what?
Yeah, absolutely. So you can share it on email, or else you can share in the WhatsApp also, or else
Yes,
in
yes. I
this
can share in
meeting.
WhatsApp. I can share in the WhatsApp as well, and you can put it in some Google Drive wherever you want. Right? I
Okay,
mean,
sir. So on the number which where you are communicating, sir, you can
yes.
provide us all the content which is which you have provided in this link in that number. We
Sure.
will upload it in the
Sure. I'll do that.
Google Drive.
I'll just send you a WhatsApp in about 5 minutes. Okay.
Okay, sir. Sure.
Thank you. So, are there any more questions from session one? No.
So I
So,
guess there are no questions. So we
we'll take
can break
some.
for 15 minutes
Yeah.
break. Yeah.
Right. So we'll take a 15 minutes break and we'll be back by 12:15 or so. Okay.
15. Huh? Yes.
Okay. Okay. Thank you.
So, dear participants, we request you not to log off from this link. Remain connected, make your system connected, and then freshen up and come back by 12:15.
So hi, I'm here.
Sir, we are present. We are present, sir. We are present.
So I think we can start.
Yes, sir. Yes.
Hello. Yes, sir. We can start.
I'm not able to hear. There's some problem. Can you guys hear me? Like,
Yes, sir. It's
Yes, sir.
audible, sir.
problem with my. Yeah. Okay. So but I think I cannot hear anyone actually. Let me just check what is the problem.
So you're audible, sir.
Everything seems fine.
Hello.
Okay, I'll just drop off and then log in again. Okay.
Okay. Okay. So, dear participants, there is some connectivity issue from the speakers end. So,
So
sir
I'll
will be
just make
joining again
EIT.
soon. So, until then, please hold on.
Just a minute.
Thank you.
Not sure what I just can't hear anyone actually. Just a minute. Not sure what happened.
You are audible, sir.
So, sir is disconnected right now. So, he will be joining soon again. Thank you.
See, I couldn't see the like Not sure
So
what
you're
is happening.
audible
I can
and
see
visible.
the AICT Academy is saying something, but I can't hear. That is the problem. Not sure. Let me
Maybe
just
some
check
headphone issues.
what happened. It's working fine. Speaker. System setting. Sorry, really sorry. Let me just check out what is happening. प्रॉब्लम था ना दैट आउटपुट नहीं आ रहा था
मैम हम लोग को कौन क्यों इंटरनेट नहीं है
वो समय restart.
So dear participants, sir is restarting his system. As there are some speaker issues from his end, so he will be joining soon once he restart his system. Thank you.
Hello, excuse me, ma'am. Hello.
Participants, yeah. Hello, Anurag sir, please tell me.
Have you shared the material in Google Drive?
Yeah, all the materials are shared. So all the materials, whatever Saurav sir has shared, na, all of that has been uploaded A9 folder.
The link material, the link he was providing.
No, that link we have provided. We have downloaded the contents from that link and we have shared in our Google Link drive in day 9 folder. The Google Link drive which you have been accessing from day 1, we have shared in that folder.
Okay, thank you, ma'am. Thank you.
Thank you. So, dear participants, we request you to kindly access the content from Google Drive link, which we have provided from day 1. In that, in the folder of day 9, you will get all the materials, whatever is been shared by Professor Srivastava.
Yeah, I can hear everyone. Can everyone hear me now?
Yes, sir, we can hear you, sir.
Right. Thanks. There was some issue with my earphone. I'm not sure. I just left it like this, but sorry for the lost time. We'll just make up for it. I hope my screen is visible.
Yes, sir. Your screen is
Yes, sir.
absolutely visible and clear,
Okay.
sir.
Thank you. Thanks a lot. So sorry for the lost time. Let us jump straight back into our second session. So sorry for this delay and a very quick recap. I'll just briefly say what exactly we did in session 1. So in session 1, we talked about what exactly are LLMs. From a basic introduction to them, and then I also showed you the importance of vectorization, because vectorization is essentially that particular building block over which this whole building of LLMs is essentially being created, right? So I showed you some toy examples of how vectorization without any LLM. We have not yet actually seen any LLM. So whatever we have seen till now, they are just some libraries, and how these simple libraries can also help you create your own small agents, something like this, right? So we saw, for example, how sentence transformer was able to produce a factoid based on the queries that we had, right? So this much part. We also saw some Python code. Of course, we did not go into the intricate details of each and every library, because frankly it will take a lot of time just discussing one particular library. We can probably talk about half an hour over sentence transformer itself, but that is the reason that I'm sharing the code with you, and I'm also giving you that requirements for THT. So I assume that you understand, you have the knowledge to use the requirements.txt. Even if you are not able to create a Python virtual environment, you can directly download something like Conda. Right? I use a very basic primitive solution like the Python's PENV solution, but more advanced users usually use Anaconda. So you can also use Anaconda, and the same requirements.txt will be helpful for you in setting up your own virtual environment. Right. So this was session 1. Let's quickly dive into session 2. Okay. So in the first session, we talked about LLMs, and now you understand how they understand and generate language. Right? The idea of generating the language is essentially one bit at a time. Right? You generate the output of an LLM one bit at a time. Generate one token, then feed it back into the input, then you generate the second token, then the third token, and so on and so forth. So we did it on a one by one basis, and so now let us move to something more tangible, right? When I say tangible, it means that whatever we have seen till now, they were just the basic building blocks. But when it comes to the real world, you are going to be posed with some actual real world problem. And any LLM that you will have, and again, I will repeat one particular assertion that I have done multiple times. An LLM is not really an intelligent agent. Right? Its job is just to understand the language. Um, the, the intelligent in the intelligence sphere is kind of implicit. Whatever intelligence it gained while processing its training data, that is the only intelligence it has. It doesn't have any intelligence beyond that, right? So that is it. We must consider this as some of the that as one of the most basic misconceptions within LLM. LLM doesn't imply that it has intelligence. Intelligence is just implicit. So what about now using LLMs for some day-to-day tasks? So for example, if I have some very long PDF, how can I use an LLM to extract some useful information out of it? So the information that I am more worried about, right? So it could be a very long PDF. It could, for example, be a PDF that has 50 pages, and I'm more interested in a specific part of that particular PDF, right? I do not want to go through the whole 50 pages to figure out where exactly is that piece of information that I want. So this is one place where the traditional NLP researchers have tried to work a lot, right? The field was called information retrieval. There are still many people who work in the field of information retrieval. However, things have changed a lot, from the traditional methods of information retrieval. We are now moving towards what is known as neural IR. Right? So that means that we are going to do IR, but we are now going to use neural networks. And we realize that this giant that we have created, the LLMs, right? These LLMs could be very useful when we are trying to do this information retrieval. So today we are going to look at one particular example where we'll use a long PDF and we will try to extract some useful information, only the particular localized useful information from that PDF with the help of an LLM. Another possible real world use case where LLMs are often very good at is the concept of
Excuse me, sir.
yes.
You are audible, but your voice is not so clear as it was previous. It is. It is.
Okay. Just give me 1 second. Yeah. Is it much better now? Or
Better, sir. Better.
okay, just a minute. I've actually applied noise removal also. Is it much better now? Not really. I hope I'm not sure whether noise removal was actually put in place in the first session or not, but I have put it in now. Hello.
Okay, sir. Carry on. Okay.
Sorry. Like I'm not sure what is the best. What is the best mode? I actually had to restart my machine, and I'm not really sure because WebEx is something that I'm not very comfortable with. I just hope it's audible enough.
Yes, sir.
Right. So let's move back. So essentially, one of the use cases that is where LLMs can be of very useful help is where you have some kind of structured database. Right? The best example of a structured database is, let us say, a table in SQL Server or Oracle or MariaDB, MySQL. Right? So let us say you have some data which is stored as part of some table, and you want to figure out, you want to query this particular table for some input. Again, this is another place where traditional information retrieval people have worked upon. At that point of time, we did not have the concept of vectorization. So it was mostly a keyword based matching, right? I would try to find out what keywords do you have in your query. Then there was things like lemmatization, stemming. It was a rule based system, right? And as you might already understand, even a small mistake from the user's side will actually make this whole deck of rules fall. I mean, uh, you can see that in our case, instead of using fruit, I used oranges, right? Maybe in a typical traditional IR system, this was enough to simply say I don't have any information related to oranges in my knowledge base. But yes, so one of the things where this so-called LLM can actually be used is if I have some data in some table, and all I need to do is I need to find out a particular query. Right I'm pretty sure you may be familiar with something like SQL. So an SQL query, if I give you a typical table, with the help of certain where clauses, I can narrow it down one or couple of one or a couple of, let us say, rows, right? Something like this. So one particular use case where I can use my LLM is to ask it to help me with generating a simple select statement. If I know, of course, I'll have to inform my LLM what my table looks like and what is it that the user wants to understand. But there are certain fine-tuned LLMs which are very good at producing, let us say, SQL statements or statements related to Python, Java, right? So there are these LLMs. I told you that even though the initial LLMs were just language experts, when people realized that these so-called language experts can be fine-tuned to produce experts of a specific field, people started fine tuning it. Right? So there are now models available which are, let us say, Python expert LLMs or Java expert LLMs or SQL expert LLMs. So one particular use case where LLMs could be used is if you have data in a table, with the help of an LLM, you can generate a typical select statement which brings out the exact row that the user wants to see. This is another use case. Another typical real world problem could be when we discussed this in the beginning, right? That LLMs usually do not like anything other than text. I mean, they are meant for text. Their purpose is to understand text. They don't work on videos, audios, images. All these things are beyond their scope. But with the help of small levels of engineering, right? I mean, you can of course use images. You can give a facade, you can give a kind of an illusion to the user. This is the kind of illusion that we will also see today, that that my LLM can actually do question answering over images, right? What I'm doing is I'm just doing some basic engineering work in the background. But and this is another kind of pipeline that people use LLMs with, that they hide the actual LLM's capabilities from the user, but you write some code in between to convert the user input into a format that the LLM can understand. So towards the end of this session, we will see a very simple example where we will feed. It will look like that we are feeding the LLM an image, but essentially what we will be doing will be some basic engineering. Right? So in this session, we are going to look at three small systems. I'm calling them systems because you are not really directly interacting with an LLM. In the first session, we were directly interacting with GPT-2, we were directly interacting with BERT, with sentence transformer. Now we are not really directly going to interact with an LLM. We are going to interact with wrappers. Okay, wrappers which inside their processing are somehow going to invoke some LLM. But for you, they are like an end-to-end system, right? You don't really know whether an LLM is being used or not. So in this session, we are going to we are going to look at three different examples of how LLMs can be used to create real-world applications. So before we move forward, there is a very popular term, right? I'm not sure how many of you have heard this term, but anyone who has ever worked on on LLMs will be able to tell if there is someone. So is the voice still not clear? Not sure what is.
Hello. Yes, sir, it's clear, but it's slightly low.
Slightly low. Okay, I'll just enhance. Hello, is it much better now?
Yeah, now it's fine.
Right. Okay, so there was some volume was down. Sorry. I hope it's now much clear, right? Thank you.
Yes, it's clear, sir.
Okay, thank you. Okay, so I'm not sure. Has anyone ever heard the term RAG? I know if you have not, if you have heard the term RAG, you might have already seen where LLMs take you, right? But in case you have not heard the term RAG, this is the first thing that we will discuss today. So what exactly is a RAG? As as you can see, it stands for Retrieval Augmented Generation. So there are two terms here: retrieval, augmented. So basically, RAG is essentially a kind of a technique where we are going to improve the response and let us say the knowledge of our RAG, right? So now the question is, why exactly do we need an improvement in our LLM, right? I mean, I told you that these guys are they were trained with lots and lots of data on the internet, right? And therefore we should possibly not be requiring to provide them more help, right? I mean, why do we need to help an LLM, right? So for this, I have an example. I don't know how many of you are movie buffs, but it's a movie called Lage Raho Munna Bhai. Don't know how many of you have watched this movie, right? But I'll just give you a very basic premise. So in the movie, just those people who have not seen it, right? It's a very popular Bollywood movie. I'm not sure about whether it was dubbed in other languages or not, but in at least in the Bollywood, what can I say? The Bollywood fans, it's a very common, very popular movie. So there was a particular. I'll just give you the premise. It's very interesting because I found this example directly mapping to modern day LLMs, right? So this is the reason that I have included this movie in this presentation. So in this movie, there is this character called Munna, and he claims that he sees Mahatma Gandhi, right? And he says that you ask me anything, and I will ask Mahatma Gandhi in turn. Whatever answer Gandhi gives me, I'll just parrot it back to you, right? So he basically says that I see Gandhi. This is the premise of the movie. And of course, the movie moves on, and at one point of time, there is, I think, a psychiatrist who decides to basically break this myth. So then he gives, he asks this guy certain personal questions about Mahatma Gandhi. Right? For example, I think, what is the name of his mother? Where did he stay in his early days? Something like this. Right? And then the character Munna starts asking Gandhi, what are the answers to this? And Gandhi remains mute. Gandhi doesn't answer. Right? And then he's really perplexed. And at this point of time, the psychiatrist essentially makes a very revealing thing a revelation in front of a large number of people. And this is what he says, right? You've read a lot about him. Him here is essentially Gandhi, but not everything, right? So your Gandhi can only answer the questions to whom you know the answer, right? So if you have read about something at some point of time in your life about Gandhi, then if you ask that question to this image of Gandhi that you're seeing, then you will get an answer. But if you ask a question that you don't know, your Gandhi would also don't know the answer. Right? So now let us come back from this detour back to the world of RAGs and LLMs. So this is exactly what is going to happen with a typical LLM. Right? So LLMs are, as we all know, they were trained on very large data sets, but even then they have a fixed knowledge cutoff, right? So if I don't know whether you are aware of it or not, but initial Chat GPT versions were they were trained on the internet state, which was around 2 years or 3 years stale. right? So the only knowledge that ChatGPT had was basically 3 years stay. So if you ask ChatGPT about an event which occurred in the past 1.5 years, in the initial days, ChatGPT would have no idea because there was a cutoff date, and ChatGPT's knowledge ended then. So this is always going to be a problem because the amount of data that you require to uh, train a particular LLM, because it's huge, you can't really do it every hour or even every day. Maybe even with huge amount of resources, it might take say a week or so to retrain, rebuild the LLM. So clearly you can't do it in short spans, right? And maybe in the best cases you might have a newer version every week or every week or something. So this means that there will always be some knowledge that your LLM does not know. In addition, there is some knowledge that internet cannot give you, right? Because this knowledge is essentially private to a particular individual or a particular organization. And even after crawling through the web, you might not reach this particular information. It's hidden behind certain security. And if you ask questions from such pieces of knowledge, the LLM will have no idea, right? So for example, if I prepared a PDF document that detailed about my day-to-day routine, and that PDF document is stored on my PC, if I ask ChatGPT about my routine, ChatGPT won't be able to tell. It doesn't know about that particular PDF. So now what is the problem? Here there is another problem called hallucination. It's something that I always talk about, that people in the computer science field, we do not uh, come up with our own metaphors and words. We simply buy and borrow metaphors and terms from other fields. So in the real world, you understand what is hallucination. In fact, in that particular movie, Munna was basically hallucinating an image of Gandhi. So the same thing might happen with our LLMs also. Even if they don't know an answer, because they were essentially trained to produce some output, right? They will start producing some gibberish, and the answers they might give may not be correct, right? And if they do something like this, you call it hallucination. Right? So I want to avoid my LLM from hallucinating. Right? So this is where our RAGs kick in. So what exactly RAGs do? So a typical RAG is essentially, as it says, it is a retrieval augmented generation. Right? So there is a retrieval here. So what exactly is a retrieval? It is a piece of code that is going to retrieve some data from a place which was currently off limits for my LLM. Right? So for example, this could be, let us say, through some API. It could be an API which is inside my organization. Nobody from the internet can directly access. So a typical retriever might be something like this, which calls up an API, fetches some data, and then supplies this additional data to an LLM on the fly. No, and of course, our modern LLMs, and we will see how it usually works, but our modern LLMs are good enough, they are smart enough to consume this new information on the fly, because they are, as I told you, they are essentially experts at understanding the language. Even if you give them some new information in plain English, they'll be able to understand it and then produce a more accurate and a more precise answer, right? So this augmented data, with this augmented data, the LLM becomes much more precise and useful. So typically, how does and by the way, we don't just call them RAG, we usually call them RAG pipelines, right? Because it's going to be a pipeline. Typically, how does a typical RAG pipeline works? You give me some user query. Now, there is some external data which is not really available to the LLM, and this is where this so-called retriever is going to come. Right? What is the job of this retriever? It is going to retrieve this external data from multiple places. This retrieval is not a part of LLM. Okay, it's something that we will write, the programmers. It is our responsibility to write this retriever. And I mean, when I say programmers, as in it's not a part of the LLM. There are frameworks today which provide you retrievers, but you can of course start writing a retriever from scratch also. Right? But the idea of a retriever is it is going to fetch some data from a source which was not directly available to the LLM, and then it supplies this information to the LLM alongside the initial user query as well. And with the help of this supply data and the user query, the LLM generates a answer. This answer will be much more precise and accurate, and may be devoid of any hallucination, as compared to an answer that it could have generated right after giving it the user code. Right. So the first set of solution that we are going to do, that we are going to see today, and this solution is a solution where you get a lot of retrievers which are pre-built. You don't have to write much code. These retrievers can do most of the heavy lifting for you automatically. So the first such framework that we are going to have a look at is Llama Index. So Llama Index is, keep this in mind that this is a framework. It's not a particular application. You can use Llama Index to create your own application. Right? It provides you for it provides you certain type of retrievers. It provides you the option to build a proper RAG pipeline, and it's pluggable pipeline. You can use one LLM or the other. You can choose which LLM you want. You can choose a specific type of embedding model. Right? We saw some embedding model examples today. So you can decide what kind of embedding model you would like. You can decide what kind of vectorization index. Right? Basically, it's a store where we are going to store lots and lots of vectors. Right? So you can decide where exactly and how exactly am I going to store some indices, and then it is also going to provide you a typical pipeline where certain data is retrieved and then it is supplied to an LLM for question answer. Right? By the way, Llama Index is free and open source, so you don't have to pay anything if you want to use it. You can try it out without any second cost, right? So this is just a simple example of how Llama Index works. So you have some kind of data with you, for example, PDFs or CSVs. You can also have your own databases. What you do is you provide this to a specific type of data loader, right? So the loader understands there are different loaders for different types of data, right? So there are loaders for PDFs, there are loaders for CSVs, there are loaders for other types of documents. In fact, Llama Index has a very vibrant, rapidly expanding community, and you can also say that okay, there is a specific type of data which is currently not supported in Llama Index. So I am going to create a retriever for it, and then I'm going to create a loader for it, and then I will just contribute it back into the open source community. So if you can come up with, and there are, by the way, integrations available for MongoDB, there are integrations available for Neo4j, integrations available to fetch data from Google Drive, from OneDrive. There are a lot of integrations which are already freely available in the Llama Index ecosystem. So you can use any of those integrations. It depends where your data is and in what form your data is, right? So basically, in some ways, the loader's job is to somehow, as I said, right, it could be PDF, it could be Word. The loader finally puts all this into a text format, right? A plain text format that the LLM can understand. The next step is to split it. Right now, what exactly is splitting? The amount of text that you are trying to load may be a bit too much for your LLM to handle. Right? I mean, imagine a 100-page PDF, right? With each page having around 500 words or so. Right? We are talking about 50,000 words, right? Your LLM will probably not be able to work with so much amount. So one of the things that we do, and this is one of the most beautiful things that Llama Index does for you, is that it essentially is going to split your text into certain chunks. Right now, I'll give you a very simple example. The 5 sentences that we saw today in the sentence transformer example. Just imagine that instead of having 5 independent sentences, if I give you a paragraph, right, that has 5 sentences, it's let us say part of the same text. And then I say, okay, create chunks of 1 sentence each. Okay, so basically what is it that we are going to do? We are going to create 5 different chunks out of this one particular paragraph. Now the question is, why am I chunking this? What is the advantage of chunking? Right? So let me give you an idea. If I have a 50-page PDF, you've asked me a question whose answer is possibly available on page number 90. Right? In a typical default use case, what would Llama Index really do is it will basically split your 50-page PDF page by page. Okay? So each page becomes one particular chunk, right? And now what would they do? What would Llama Index do? It will find their vector embeddings. I told you vector embeddings could be found for one word, for a couple of words, for a sentence, for a paragraph. So you can create a complete vector embedding for, let us say, one page of the PDF and then store this vector somewhere for later use. And this is where the vector index is going to come into play. So whatever text I have, which is supposed to be loaded, the text splitter is going to decide what is the best way to split this text. A very simple example for PDFs would be that you chunk it page wise. And then what do? You basically create the vector embeddings for each page. And then you store it in a simple vector index. Okay, so this is, let us say, the pre-processing part of my pipeline. Right? I just do this offline when I'm free, when I'm not really working with a user. I do it offline, whatever amount of time it takes, and I prepare the storage, and I'm now done with it. At this point of time, the user gives me a query. It asks me a question. And then what do I do? At this place, I essentially create a vector for this user query as well, using the same technology that I use for creating vectors of my pages. So then what I do is I do a vector search, right? Essentially, I'm going to take this vector and I'm going to match it with all the vectors that I have in my vector store. So for example, if it was a 50-page PDF, I'll probably have 50 different vectors. And then what will I do? The very same thing that sentence transformer was doing with those 5 sentences. I will start finding the vector similarity between the user's query, the user's vector, and the vector that is stored in the vector storage. Now imagine that you might say, okay, then in the case of sentence transformer, I just showed you the best possible match and it was doing quite well. In many cases, I would say, okay, maybe there is an overlap. Okay, the answer was not just on page number 19, but maybe something was on page number 19 and something was on page number 20, or it was split across page number 18, page number 19, and page number 20. Now, if my vector embedding solution is good, essentially what will happen is the vectors for page 18, 19, and 20 will be very close to the vector of the user query. So usually what I do is I try to retrieve the top n. The value of n depends on my application. Okay. What is the most common value of n? In most cases, the default value that Llama Index takes is either 3 or 5. This means that not only am I going to consider the vector which is closest to the user query, I'm going to bring the top 3 or top 5. And then what do I do? For these 3 or 5 pages, I look at the text that was extracted by the text split. Okay? And then the text that was there on page, let us say 18, 19, and 20, I send this text to my LLM. I say that, hey, I have some piece of knowledge for you. It's like saying, I have a story for you. Here is the story. No, Ram was a king of Ayodhya. No, he, Sita was his wife. Lakshman was his brother. So you just say some 10 different sentences, and at the end you say, now can you tell me who was the husband of Sita? That is the kind of idea we have. That essentially whatever knowledge is required to answer this user query, I first retrieve it from my own storage based on a vector search. And then I just concatenate this data together and feed it to my LLM. And at the end of this information, I ask it a question. Right? It's like saying that I'll tell you a story, then you answer, then you give me an answer from the story. Now, because our LLMs are very good at understanding languages, the moment you give them this information and you follow it up with a question, they're able to they're able to uniquely or in many cases precisely give you the output, the answer. Right? They are now able to generate the best answer for your query. So this is a typical RAG, right? This is how a typical RAG works. Just to summarize this whole, it might be a little overwhelming. This is a very long flowchart, but I'll just summarize this whole process again. Whatever data I have, I need to first split this data into manageable chunks. Now, what is manageable? It depends from one use case to another, right? But typically, I would say try to split it into 500 words or so. So it's a rough estimate. It could be more, it could be less also. But let us say try to divide it around 500 words or so. In many cases, having one page of PDF is pretty much equivalent to that. It's not a hard limit. It's an average thing that happens. Now, for each of these chunks, create a vector, right, which essentially encapsulates whatever information was there in this text, and store this vector somewhere. So all the vectors are now stored offline somewhere. When the user gives me a query, the user query should also create another vector. This is the query. And now, assuming that the user's query is answerable from the data I have, we are going to have a vector search, and we'll find out the top n closest texts that I have available with me. I'll take out the original text, not the vectors, the original text which produced the vectors. I concatenate them together. I pass it to my LLM, and then just like saying a story followed by a question, I ask my LLM for the answer, and the LLM answers this. So you can now see that if I had a PDF of my own where I was talking about what I do on a day-to-day basis, if I can somehow provide this as part of a story to ChatGPT, then ChatGPT will be able to tell me that, oh yeah, you usually have lunch at 2:30. But without that information, that story, ChatGPT will not be able to tell. Okay. So at this point of time, by the way, in that same link, I have updated the resources for session 2. I hope it is available to everyone. So let me now stop this. And share my other screen. So is it visible to everyone?
Yes, sir.
So let me first show you what exactly is it that we are going to work with, right? I'll show you. I have a folder called data. In this data folder, I have a simple PDF, right? So let me just show you what this PDF looks like. This is a PDF which was, oh sorry, you can't see the PDF. I'll show you the PDF as well. For a moment, I'll just share the whole screen. Can you see the PDF that is currently open on my screen?
Yes, sir. Yes, sir. Visible.
Right, it's a very large PDF. And what exactly is it? It is basically the speech of our finance minister, Nirmala Sitharaman, and it's a very large PDF. You can see many pages of this. quite a lot of pages, right? More than 50 pages. So now you understand that this is a very large PDF, and let us say you only want to know about just something, right? Not everything. You just want to know about, let us say you want to know about National Center of Excellence for Skilling. That is the only thing, right? Or expansion of the capacity in IITs, right? So let me. I'm only interested in knowing about this part, right? I'm not really interested about anything else, right? But in order to do that, I'll have to go through this PDF and figure it out. Right? So now let us go back to our let me show you what we have here. I have a simple, very very simplistic chatbot. On this. Oh, sorry, I have not yet activated. Takes a little bit of time. Okay. I hope you can see this guy, right? There is something coming up here, right? It's a very simple, two-section window. Let me ask it some question. What was it that you were looking at? Expansion of IITs, right? So, what is the news of the budget speech proposes additional infrastructure will be created in 5 IITs started after 2014 to facilitate education for 6,500 more students. Additionally, hostel and other infrastructure capacity at IIT Patna will also be expanded. So there is something it has. This is basically the part where it has read. Now let us go ahead and try to find something else. Let us say this PM Swan. We can ask, how many street vendors were benefited by PM Swanity? Ask this. And say how many vendors were benefited by Swanity. It says more than 68 lakh street vendors have been benefited by PM Swanity. So what exactly is happening here? Right? It's a very large. It's a PDF that has more than 50 pages, right? So how exactly is this so-called small guy, able to extract the exact information I want and then produce an answer out of this? That is the magic of Llama Index at work. So let us close this and now go back to our terminal. So this UI chatbot is a very simple thing. This is essentially. By the way, this is used. It uses TK Inter. It's a library in Python. TK and again, it's out of scope for me to discuss how TK works. But basically, it's a library with the help of which you can create some basic UI. You can create text boxes. You can create buttons. You can create all these things. It's all possible to do. But basically this so-called TK inter thing, it can help you with creating some basic UI. Right? Now, what exactly? So this is just the UI. So let us go to our core part, right? The Llama index part. So the first part, I told you that there is some kind of offline processing that is supposed to be done, right? Without that so-called offline processing, I do not have the power to be able to do it. So in this so-called offline processing, what exactly is it? And first of all, I'm picking some embedding model. It's a specific embedding model which is used by which we are using. This is a more recommended one to be used with Llama Index. I mean, there are many embedding models. You can change this to any other models. This is what is recommended as the default, so we haven't changed it. And here I am also setting that the LLM I want to use for my application is Mistral. So Mistral is a mid-sized LLM. It's not too large. It's not too small. So basically, it is quite useful for small applications. You know, the applications where you do not need a lot of fancy stuff. It just works, right? I mean, it can hallucinate at times. It might give you the incorrect answers at times, but I would say maybe 7 or 8 out of 10 times Mistral works, right? So we are using Mistral. So our LLM here is Mistral, right? And then this is where the offline processing works, right? I mean, I say that there is a particular directory, the data directory. The job is just find out all the documents which are there, and then with the help of a particular document loader, we are going to create we are going to create a vector index, right? We are going to create some vectors out of these documents. Now keep in mind that what we are doing here is everything is default. By default, what Llama Index does is that it essentially splits a PDF page wise, right? Some are and maybe with some kind of overlap. The overlap is required because sometimes a sentence might actually end abruptly in the middle, at the end of a page. So in that case, you might miss the required context, right? So you might say, okay, we will take one page plus, let us say, the next 50 characters or the next 50 words or the next 100 words from the next page. So this is typically a most common way in which Llama Index breaks up a large PDF. So, and then what does it do? It essentially goes and stores something in a folder called storage. So you can see there is a folder called storage here. So what happens is, so check something. There is something stored here, right? I mean, this was not created by us. Okay, it was created when we ran this create storage.py. At that point of time, these files were created. And what exactly are these files? These files are storing the vector information about each and every chunk of that particular budget video. It's the job. Now, you can see that there is a file called main workflow.py. In this so-called main working.pdf, in the main workflow, what exactly is it that we are doing? We are basically taking up, the questions that that the user is asking, the things that you are typing there, right? And then what we are going to do is we are basically going to load that same index that we have created. It is stored in the storage folder. This is the place where it will find it, right? Now it creates a chat engine, right? This is basically where Llama Index comes into picture. And then with the help of this so-called chat engine, you understand the overall pipeline, right? This pipeline is not explicitly created by us here. This is done in the background by Llama Index. It has some default value of n. So what will it do? The chat engine will basically take up your user query. It will start the indexing part. It will go into, check the index vector. It will find out the top n results. It will paste it and give it to the decided LLM, and then whatever is the output, it simply puts it here, right? This is what it says, the assistant. This is the response from the assistant. So you can see that only maybe, other, if you leave out the UI code, maybe this whole code will possibly be less than 50 lines of Python. And this so-called 50 lines of Python can generate something so beautiful. This is the power of Llama Index, right? So Llama Index as a solution, it has become very popular today. A lot of applications are being built here. And you can see why, right? Whenever you have some new PDF that you want to have a question answer with, you can just create a folder like data, and you go and simply drop your new PDF into the data folder. You run the create storage part again. It simply recreates all the indices that were there till now. And once the indices are ready, you can ask the chat engine to take up a user query and perform all those steps that we saw in that so-called flowchart and come back, right? So you can no, I think this is something which will be quite interesting for you. It's a we decided to use the budget speech because it was a very long document, and we thought maybe maybe somebody can actually use it. I'm not sure how useful is the budget speech for each one of us, but just imagine maybe you can have a document that explains income tax rules. If I build an agent that can somehow understand income tax rules and help somebody in filing the ITR, let us say, or if I can build an engine which can explain the process of admissions into, let us say, IITs or AIMS, right? Let us say, explain to people what is the difference between JEE Mains, JEE Advanced, or what is when does need occur. So you can see where exactly is this going. If you want to use Llama Index, there are so many common use cases that can directly be served up with very little amount of code. I have given you, the basic code that is required to work with Llama Index, but the opportunities are vast, right? You can use this code the way you want, and you can come up with your own applications, right? With using pretty much the same infrastructure that we just saw. So this brings us to the end of the demo of Llama Index. Llama Index was something that is very important today, especially because it requires very little setup time. I mean, you can just set up Llama Index very quickly. Maybe within a day's time, you can set it up to answer queries from custom data. So let us go back to our presentation. So we are done with the Llama Index part. So let us move forward, right? So Llama Index, as I said, I have been all praise for Llama Index till now. I told you maybe with less than 50 lines of code, you can create an agent which is intelligent enough to answer questions from large, boring PDFs, right? And provide answers to users who want help from a specific section of that particular document, right? So one analogy that I can give for Llama Index in the real world is that Llama Index is like a well-crafted kitchen knife, right? It's a knife which is sharp, efficient, and it is perfect for common tasks, right? A lot of things, you know that our kitchen knives, we don't just use them in the kitchen, right? We use them at different places wherever we want something to cut. We bring our knives from the kitchen and use them. So Llama Index, as I said, is a very nice, very useful uh, framework when your use cases are simple, straightforward, and they can, as I said, right, they can be done in, let us say, one shot data level, right? You only have one particular place where the data is being put. There is no complex logic involved, right? Either the data is there or it is not there, and it's a simple question answering system. So for such cases, Llama Index is arguably the best solution today, right? But we know that life is not really that simple. Sometimes a kitchen knife is not enough. If you see this documentary called Man versus Wild, there is this guy called Bear Grylls, right? Bear Grylls doesn't have a kitchen knife. So kitchen knife might not be enough in survival situation. But typically, you might want different types of tools in your hand when you are in a jungle, right? You can't just use kitchen knife everywhere. So you can say land graph, okay, another option that is available today for making practical applications out of LLMs. Land graph is one such Swiss Army knife. Right? It's a knife, as I said, it gives you a plethora of tools, which can make your RAG really flexible. The downside is, right, you can already see what the downside would be, right? Using this Swiss knife is going to be really challenging as compared to using this knife, because there is a learning curve involved. You can't just start using LangGraph today and produce an application tomorrow, right? With Llama Index, maybe you can do that, but with LangGraph, there is a learning curve involved. You have to look at it. You have to think about what exactly is it that is supposed to be built, and only after that you can start with LangGraph. So, but the advantage of LangGraph is you can build multi-step workflows and handle conditionals or loops, right? So, what exactly is multi-step workflows? Typically, if you see in today's ChatGPT, um, it has a very nice multi-turn accuracy. When I say multi-turn accuracy, it means I asked it some question and then I ask a follow-up question. When I do a follow-up, I don't have to give every bit of information that I gave in the first term. I can simply ask follow-up questions very quickly. So for these, but then again, you can understand that with Llama Index, it's not that easy. You can do that with Llama Index as well with some memory elements. But the moment you start making my life more and more difficult, Llama Index becomes more and more tricky, because it's pretty much like, as I said, it's pretty much like a kitchen knife. You can't out of the blue turn it into a cutter like this one, right? Like a scissor. So that is the problem that you will face in certain applications, and in those cases, LangGraph is a go-to option. So what exactly is LangGraph? LangGraph is a framework that can build LLM workflows which look like a graph. So where exactly is a graph coming in? So unlike so till now, the invocation of a RAG that we saw, it was pretty much like a chain, right? I can tell you this is step 1, this is step 2, this is step 3, so on and so forth, right? There were steps, and you simply followed the steps as it is. Whatever was the user query, our application followed a simple chain of events, right? In fact, this is the initial days of LangGraph was basically LangChain. I mean, LangChain is still available; it's not yet gone. But LangGraph is basically an extension of LangChain. So Llama Index could be considered as a more polished version of LangChain. That essentially there is a particular chain of things that you want to perform. Llama Index does some of these things automatically. Right? You don't have to actually do it on your own, but it's all, let us say, processed under the hood. But then people realize that in many cases it's not really a chain; it's essentially a graph, right? So, for example, and by the way, another aspect of LangChain is that it comes up with certain tools, right? So what exactly a tool? What exactly does a tool do for you? Basically, tools have very specific properties. For example, you can say that there is a tool which understands mathematics. You can ask a tool that there is a user query, and it says, the user query says, what is 5 times 6? So if there is a mathematics related tool, it will give you the answer as 30, right? Keep in mind, LLMs are not meant to be intelligent, right? They are very good at understanding language. They might be ridiculously poor at understanding, let us say, understanding something like mathematics. Even basic mathematics might be difficult. We had in fact done some. We actually learned it the hard way as well. We were so overconfident at the capabilities of LLMs that one day we also did some experiments, and we simply gave our LLM 5 numbers, and we asked, okay, just give me the average. to our surprise, our LLM was giving incorrect averages, right? Why? Because it was just predicting based on the next most possible keyword, right? There is no concept of mathematics inside an LLM. Right? So these so-called tools that are available in the LangChain ecosystem, they perform specific tasks, right? So you can, for example, do a Bing search in the tool, right? You give it some input, and it will do a search over that input over Bing and return to you the results, right? If this is a page where you can go and figure out what are the different tools. I think there are thousands of tools which are available on this site, and they do all types of things. There are, like you can see, document loaders, vector stores, embedding models. So many things are available with LangChain. So what exactly is the key idea that is used in LangGraph? Because of course it's a graph. The key idea is that at some point of time we are going to create graphs, and there are two things that creates a graph. There are nodes and there are edges. Right? So what exactly are nodes? So nodes are basically step maybe after fetching relevant data. After the third step would be whatever is the input, we are just going to summarize it in the output. So all these are different steps. Then
Sir,
we
your
have
PPT is not visible.
oh um, I just kept saying no, when did it become invisible? I know. So till what point have you seen, like was it visible here when I was? Is it visible now?
Now visible, sir.
So I mean, was this part visible to you? Like, did I talk about this and it was
It is visible. It is done right. Yes, yes.
okay? So right. So let us now. I'll just say again. So basically, the key ideas associated with lang graph is, and in fact, for any graph, what are the two things you need? You need the nodes and you need the edges, right? So in typical lang graph scenario, how does it play out? The nodes are the places where you write some processing code. Right? You do some actions on the nodes, and then there are these edges. These are basically links that basically takes you from one particular node to another node. So, for example, I can say something like this: the user has. Let us go back to our budget example. I'm just, let us try to understand it. Maybe alongside budget, I also have the income tax period. If I would be using land graph, the first step, at step one, I will try to use a simple classifier, a machine learning classifier. And I would say, hey, classifier, tell me that the user query, whether it is related to income tax or whether it is related to budget. So the classifier with some accuracy tells me, oh, this is related to income tax. So from here onwards, I'll take a different path. Okay, I'll take a different node where we are doing some income tax related processing. Maybe income tax rules are not in PDF, it is in some CSV or some other format, right? So I'll need a CSV based mechanism or something similar. Or if the user's query is related to budget, I'll go to another node. Okay, there is a different node that processes the budget period, right? So the work of the edges is basically they are going to have some conditions, and with the help of these conditions, we decide that what would be our next step in this multi-step workflow, right? So think of LangGraph as some kind of a visual programming model where you can say something like if node A gives result X, go to B, otherwise try C, something like this, right? So it's something like this, a very simple example. You start with parsing the query. You can use some kind of a text classifier at this point of time. The text classifier might say, yes, this is a structured query. It requires you to go and create a select statement, right? Or it might say, no, this is not something which is stored in the database. Maybe this is something that is stored in the PDFs, right? So in this case, you might need a RAG. So based on a decision by the text classifier, you either take yes or no. And then in either case, okay, whatever is the final output, you might give it back to a particular node that takes up the story and with the help of the user query produces the final answer. So this is an example of the kind of use cases that you can implement if you have lang graph at your end. Right? So in we have till now we have seen the PDF question answering, and I told you that Llama index was very nice, right? We simply dropped a PDF in a particular folder, wrote some 20, 30, 40 lines of Python code, and from there onwards, Llama index basically took up everything. I didn't even give it, all the defaults were working. I didn't tell it that whether it should split paragraph wise or page wise. I didn't even tell it whether it should use, the value of n should be 5 or 3. Whatever were the defaults, it simply worked for me, and so I don't need to actually care about it. Right? It's quite good. But when it comes to structured data, we need to think a little bit more, because now we are talking about data which is stored, let us say, in a table. So just giving you one particular row of this table might not make sense. You also need to know what are the data types of each and every column in this table, right? Without telling you that the first column is name, the second column is, let us say, employee ID, the third column is department. If I don't give you this information, just giving you something like Saurabh Srivastava, CSE 1286, an LLM might not really understand what do you really mean. Who is Saurabh Srivastava? What is 1286? What is CSE? So you might need some more information that needs to be provided to the LLM in order for it to be able to process your queries properly, right? So in such cases, a PDF based, instead of using a PDF based loader, we have to have a different kind of an approach, right? And this is where we are going to use LangGraph. Keep this in mind that we can use Llama Index also. There are retrievers available for CSVs in Llama Index. But just to showcase, LangGraph, for this particular use case, we are going to use LangGraph. Right? And now the requirement that we have is, let us say I have a table. Let us say it has some stats, stats related to, for example, cricket. Right? I have collected some stats related to popular players of the world. I have put it in some kind of a table, and then I want to answer questions like who has the highest score among the Indian batsmen. Show players who debuted before 2010 and took more than 50 wickets, so on and so forth. Right. So as I told you, the LLMs may be very good at language, but they are not necessarily good at logics or, for example, joins. Right? Join is a very complex operation. Join is an operation where you need to take up one particular column from one table and then take another column from another table. It's not that simple, right? In many cases, it might actually fail. So here again, if you remember, the whole idea of a RAG was to help our LLMs in in producing the right output. So now we will go one step ahead, and we'll say not only do I need help, not only we are going to help you, you can also help us the halfway. Right? When I say halfway, what does it mean? Instead of asking you to direct, I will not give you the whole table, because the table might have a million entries, a million rows. What I'll do is I'll basically give you the structure of what the table looks like. I'll give you what the user wants, and then maybe if you can give me a select query, a SQL query, as an SQL statement that fetches the correct data from the table. After that, I'll give that short amount of data, a couple of rows, a few rows to you, and then you can create an output for me from the informed data, right? So basically, now the whole pipeline looks something like this. We are going to, ask our land graph installation to process a particular query. We are going to ask it to produce a select statement out of it. We will execute this select statement offline over our database, fetch this data, and then so we are going to fetch this data and then resupply it back to the LLM and then ask it to frame an answer for it. So now what is the difference here in comparison to Llama Index? With Llama Index, my LLM came into picture at the end. Right? I did all the vector related searches. I found out what are the most relevant things that are supposed to be given to the LLM, and only over that relevant information did my LLM work. Here, there are going to be two invocations of the LLM. Okay, I'm asking my LLM to first help me out with creating a select query. The LLM helps me with this. I use that select query. I run this query offline, without informing the LLM. I fetch the relevant rows from the dataset. I then supply the text of these rows back to the LLM alongside the user query and then say, hey, now can you please tell me what would be the answer? So now you can see that there are two invocations to the same LLM. In a typical, what can I say, a typical professional LLM or professional LLM solution like ChatGPT, in one particular invocation, the LLM is called multiple times, maybe 5 times, 6 times, 7 times. I don't know whether you have ever seen this or not, but sometimes when you give some input to ChatGPT, it starts scribing something. It writes something and then it vanishes. Then it writes something else and then it again vanishes. Then it writes something else and maybe after the third time it starts producing the text. So what exactly is happening? Basically, it is a call. It's a chain of calls to the same LLM, right? We are after each chain, after each call, we are doing some amount of processing, right? And at the end of it, we essentially receive the output. And as I told you, there's just not one particular chain. Dependent on the logic that we have implemented, there could be multiple chains, or as I have just explained, it could essentially be a graph. So at this point of time, let us now move towards a very simple demonstration of the capabilities of land graph. I hope it's visible to everyone.
Yes, visible.
Yes, sir, visible.
Okay. So we are now in the land graph domain, right? We have a DB. So by the way, we are for this particular example, we are using SQLite. So SQLite is a very lightweight database. It's a database that you don't really need to install, right? You can just store your database in a typical file and then use select queries over there, right? So SQLite is more popular with mobile developers because over a mobile device you don't typically need to install something like a SQL Server or MySQL, right? All you do is you just store data in some database and then you retrieve it. So for such cases, we have this so-called DB that is available, and here I have a CSV file. I can just show you what it looks like. So basically, it is name, country, type, runs, debut year, max score, wickets, so on and so forth. Right? So there is some data that I have put in here from for certain players here, and this is in the CSV format. With the help of our code, we have simply converted this particular CSV into an SQLite table, and this so-called cricket.pp is basically just taking up the CSV and converting it into a typical database. So let us start with land graph. So here we are going to define a graph, and there are 3 nodes in my graph. The first node is called the parse node. The second node is called the execute node, and the third node is called the summarize node, right? So what exactly is happening? The parse node is basically the node where we are going to parse whatever the user query is, right? And then there is a function called get SQL from query. This is something that that is going to give us the query. In the second state, once you have the SQL, what do you do in the next step? And by the way, this is where the graph is getting created. We are adding nodes, then we are adding edges. So there is an edge from parse to execute, and there is an edge from execute to summarize, right? This is a very simple example. Even as essentially, this is not really a graph. It's essentially a chain only, right? We are not putting too much of complicated stuff here, but it is just to give you an example that you can write any amount of Python code here. You can put some conditions here, and with the help of which you can put conditional edges as well. But for now, just look at what we are going to do. There is some database. In fact, let me just open up that database. I forgot which players are there, or maybe we'll just try out. I'm not sure whether those players are already there or not. Right? Ask a question about players. I did see Virat Kohli was there. So maybe I can ask how many runs Virat scored. What happened? I think, oh, it had talked about total runs. So see, it got confused. Our Mistral guy was a bit confused between runs and total runs, right? Let me just check out what other data I have. Maybe something relevant we can ask. Total runs, right? Maybe debut. Okay, wickets seem to be a very clean thing to ask, right? Maybe I don't think Mistral um, will be that confused with wickets. Let us try wickets. We can ask who is the highest. So you can see what exactly is happening here, right? Our LLM generated this SQL query. Right? Select name, wickets from players, order by wickets, DESC. That means it is going to sort it, with the greatest entry first and the smallest entry at the end, and then limit one. So this will essentially return only one row, and that row will be of whomsoever is the highest wicket taker. I think say Shakib Al Hasan. Must be somewhere here. Shakib Al Hasan, right? This guy has 301 wickets, right? So this is possibly the reason I don't see anyone having more wickets. And maybe then I can also ask about runs as well. Who has maximum total runs? It was not able to talk about runs, right? So total runs is something that it actually understood, right? So it is saying Rohit Sharma. Again, we'll have to check where is Rohit Sharma in this one and how many runs are mentioned against Rohit Sharma. So the idea here is that we have created a typical pipeline where we are going to call our LLM twice. Okay? In the first case, we give the LLM a typical prompt. Let me check where we had written the prompt. Um, Yes, this is a prompt. Okay, this prompt says you are an expert SQLite assistant. Given a user query, generate a valid SQLite SQL query. Use exact column names as in the players table, and this player table looks like this. Okay? Do not use white spaces in column names. Respond with SQL only without any markdown. Okay, blah blah blah. So what exactly is this? I told you that essentially we are going to provide a story to the LLM, and then the LLM tries to complete the story. So here the actual user query gets pasted at this point of time, right? So this is going to be told to our LLM all the time. All the time you are going to say all these things, and then you will just put the user query here and then ask the LLM to generate the SQL statement. Then the summarizer basically says, this is again another prompt, summarize this result table, and then there is some text, right? This text is basically whatever text you receive from that particular database. It could be one row, it could be a couple of rows, it could be more rows. Essentially, this is like the story. You put the table text here, and then you ask our LLM, this is the last step, to summarize this particular result. So what exactly have we done here? We have created an invocation of LangGraph where we decouple the processing of of query from the actual data retrieval. And while we are using Mistral for both LLM invocations, in theory you can use two different LLMs for two different stages. So maybe there is one LLM which is very good at parsing, right? So you can use it in certain cases. And then there is one LLM which is fine-tuned for summarization. So in the last step, you might use another LLM. Right? So here we use the same LLM, but in theory, it is possible that we use multiple LLMs at multiple point in time, right? And this is what I told, that this is what I meant when I said that LangGraph is like a Swiss Army knife. You can use it in different ways, right? You can use it in a very customized fashion to create your own outputs, right? So we are already running out of time, so I'll just stop here and we'll move back to the presentation. We have one more thing to look at. Okay, so till now, whatever I have shown, the code was executing on my machine, right? I mean, in fact, whatever we have seen till now, were basically in-house LLM use cases, right? And the in-house LLM use cases are fine. I mean, you all understand the importance of having in-house LLM. You have privacy, your data doesn't leave your organization, and everything is good, right? But then, in most cases, you would see that an open source LLM will probably never be as good as an enterprise grade LLM, right? So something like Mistral or Llama will almost always lag behind ChatGPT 4 or Gemini 1.5 when it comes to end-to-end use cases, reasoning, multi-turn. And in addition to that, even to run a very let's say moderate level of LLM like Mistral, you will need a system which has some where you have around 8 to 16 GB of virtual RAM available. So an 8 to 16 GB virtual RAM available for Mistral would possibly mean that you will need a 32 GB RAM machine at the least in order to run it. And for fine tuning, you might need machines where the RAMs are even much higher. So clearly, this we have already talked about, that these kind of resources are usually not that easily available on premise, and this is where our hosted LLMs, especially by providers like OpenAI and Google, can come into picture with relatively small subscription fees, right? So here, what they do is they provide you APIs to access their LLM, right? So till now we were giving inputs to LLMs and getting outputs. Now you can do that over internet. You can send inputs to their LLMs and get outputs from their LLMs instead of hosting them on your own infrastructure, right? Of course, you will need some API keys. And by the way, this particular example that I'm going to show, I'm able to run this because I have some credits that I purchased on OpenAI. If you want to do this, maybe you will have to purchase something. I'm not sure whether they provide any free tier. If they do, then it's very good, but otherwise you will be requiring to purchase something. This is the problem with these LLMs, that we'll have to purchase their subscription. So what exactly we will do today as part of this last example? So I told you in the beginning, the LLMs don't work with images, right? But one simplest way in which you can give an illusion that your LLM is working with images is by using something as simple as OCR. So OCR stands for optical character recognition. Optical character recognition is a very simple yet very powerful a very powerful tool. It was developed as long as maybe 30-40 years back, but in 2005 we had some kind of a revolution in this particular domain. Tesseract is basically a library that is currently being maintained by Google. It's one of the best state-of-the-art libraries for performing OCR. So in typical OCR, it means you give me a picture, I will read it, and I will try to extract whatever text is written. Right? That's it. That's all OCR will do. It will not try to find out relationships between the text. It will not try to find out what text is in high fonts, what text is in low fonts. It will simply extract the texts out of the images, and then you can put this so-called text in a particular file, and this file becomes your input to your LLM. Right? This is what we are going to do today, and right. So using OpenAI's API, you can use. There are multiple GPT mod. There are multiple LLMs that are available here. You also can directly send audio files to them, and they will of course convert it from speech to text. And as I said, these are all illusions. The actual LLM is not going to work with all these things, but they have wrappers available for audio and image and so on and so forth. You will need to create an API key from your OpenAI account, and this, as I said, will require you to pay some money. So now we are going to look at the last demo of this particular session. Stop this. So let me show you what exactly is it that we are going to do. There are two files here. This is the first file. I hope you can see my screen, right? So this is the first file. It is just a screenshot of the IIT ISM's web page. Right? It has some images and some text, and then this is another file. It is some notice that came from the office of Dean Academic, right? And it has some text, some signatures, things like that. So now what we are going to do is we are going to do some. Let me also show you what this so-called UA.py looks like. So this is a typical question answering thing. What we'll do is I'll ask you for the name of an image file from where you are trying to do some question answer, right? So it's as if you are uploading this so-called file to my LLM for question answering, and then I will ask you to ask some questions, right? So let me just run this first. Let's start with sample 1. There was now something related to Uh, Sample. This is the file. Um, let us call. Let us say who organized the meeting, right? Let us try to see who organized. Oh, so this is sample one, right? Sample one is this one. Right? So it's talking about some ranking that we have. Right? So let us say what was the ranking. It says IIT ISM Dhanbad was ranked 41st in the QS world ranking, coming from here. By the way, this is not text. This is image. So how exactly was this possible? Let me show you how it was possible. There is this file here. It is just yet created, 1358. Just now. What exactly does this file has? You can see what this file is. Okay. If you go back and see, it is just the text out of this file, which is present here, right? Now let us give it the second in the other file we had. Let us give it sample. This is this particular. So we can ask it about, let's say, the date of the meeting, right? When was the meeting held? The meeting was held on 20th. Now, what exactly? And again, you can go and check what is there in this file. Now, so the content of the file has changed, right? This is coming now from here. So what exactly is happening? Basically, at this point of time, I'm just using Tesseract, our Google's OCR solution. Whenever you give me a particular image, what is it that I do? I'll run Tesseract through it. I'll extract its text into some particular file. And from here onwards, it is pretty much like a RAG. Okay. What do I do with the RAG? I just send this story to ChatGPT and I append the query that the user has asked at the bottom. Very similar to what we were doing in the case of Llama Index and in the case of LangGraph, right? And then after reading this whole story, ChatGPT actually knows about this particular meeting. If you ask ChatGPT about this meeting straight away, it would have no idea because this was an internal circular. It was not something that was circulated outside the institute, right? So ChatGPT would have no way to know this, right? But by creating a RAG out of it, essentially, we are sending this data to ChatGPT and then asking it for some questions which it is able to answer. So I know I've already run out of time, but let me just finish off the session by summarizing things. So what have we done in today's two sessions? We explored the concept of an LLM, right? We discussed what exactly does an LLM do. We talked about local models like Mistral. We used more Mistral, and then we also talked about hosted LLMs like OpenAI. We then discussed how to do question answering from text documents like PDFs as well as structured databases. And we also saw, so even though it was just a simple chain, I gave you an example of how LangGraph could be created. Right? You can create graphs, you can create edges, and these there can be transitions from one place to another. You can have two invocations to the LLM in the same query from the user, so on and so forth. And then some of the tools we talked about were Tesseract for OCR. SQLite, as I said, is something that you can use in case you want to have a database, but you don't want to install anything. We talked about LangGraph, for building conditional workflows, and OpenAI APIs for advanced LLM capability. So key takeaways from today's sessions are that LLMs are not just chatbots. They can be embedded in real-world applications. In fact, ChatGPT is not really an LLM. It is basically a wrapper over some particular LLM that OpenAI guys have built. For example, GPT 4.2 or 4.5. And you can choose open source or enterprise grade models based on whatever are your needs. And tools like LangGraph can build very complex applications, but of course there is this learning curve that is supposed to be used, that is supposed to be followed. And then hosted APIs, they can simplify the deployment, but of course you are going to give away the privacy, right? So with this, we come to the end of this marathon 4 hours, little less than 4 hours long session. If anyone still has any questions, please ask.
So dear participants, if you have any query, please let us know in the chat box section, or else you can unmute yourself and directly interact with us.
Am I audible? No, sir, final.
Yes, sir, you're audible.
Like chat box and what you have shown, sir. So it just gives the response from the given data, or it does analyze things as well. Like if I give the runs of my batsmen, and if I say chat box, what is the total of total runs by scored by all the batsmen? So will it give the, and will it analyze that, or it will just give the data what is there in that?
No, so in this case, if you see, the analysis is not being done at all by the chatbot. So what yes, so what we do is we simply say, hey chatbot, there is a user query, and you know something about SQL. So can you convert this user query into an SQL statement, right? So basically there and that is why it can come up with an SQL statement that doesn't return any rows at all from my data set. Right? So for example, if I say I want to know the runs scored by Akashdeep, right? Now I might not have Akashdeep in my data set. But what would the LLM do? It will say, okay, select asterisk from table where name equal to Akash. So this is where the LLM will end. It will not go anything beyond that, right? Right now, it is my responsibility to execute this, find out whatever rows are available in the database returned by this query, and then I will refeed it back to the second invocation of LLM. And I say, hey, I have some results. Can you simply summarize the results? Okay. Now, the problem here is the first invocation doesn't really know what data is already present in the database. And it is quite possible that while I do the second invocation, I might do it with some empty data. So I need to put in more checks, right? So that such things can be handled. So maybe I should apply more nodes in our LangGraph to look for these kind of cases. But as of now, the only analysis that I'm asking my chatbot to do is to prepare a SQL statement out of the user's query.
And one more question I have, sir. Like, there are subjects like LLM, large language model in computer engineering somewhere. So that and these are same, or that is something different?
No, that is what we discussed, right? Large language
That is
model.
what we discussed, no?
Yes.
Okay, sir.
Any other queries? All right. So if there are no queries, thank you all of you from my end. It would have been very difficult to keep your to be focused for such a time. I just hope that this session would be of some use to you. And I've already shared the resources related to this session with the team, as well as the link which I had updated before, right? It also has the same resource.
So thank you, sir. So on behalf of Professor Gaurav Trivedi, sir, the Principal Investigator of E&ICT Academy, and on behalf of Dr. Aryavurtha Sahu, sir, the Principal Coordinator of this course, I thank you, sir, for accepting our request to deliver a class in this course and coming up in this platform and enlightening all our participants. Thank you, sir.
Thank you.
So dear participants, the MCQ tool link is activated. So we request you all to kindly go into the link and solve the questions and submit it by 3. The link will be activated till 3 only. After 3, the link will be deactivated. So we request all the participants, if you have any work, then please take out some time, 10-15 minutes during this period, and please attempt the MCQ. যদি আপনি রেজিস্টার করবেন এই সময় আপনার কমপ্লিট থাকলে আপনারা রেজিস্টার করবেন আরে না এখন প্রাইস না দেওয়া সাইজ করতে হবে चलो Ranika, तो स्कोप वाला दुविधा तो उसमें इंटर यार इंडस्ट्री पार्टनर ट्रेनिंग पार्टनर है जैसे कि रिकमेंड करें और उस एमओयू ना Responsibility of yes is reports identification and examination. Oh, same balance.
Total responsibility. There's something there. Say. Wait.
Hello. Hello. Yeah, dear participants, this is an MCQ. Okay, and single correct option is there. Okay. So at a time, you can select only one single answer. Thank you.
Ma'am, can we leave the meeting?
Yeah, sure. Those who have no queries and those who can find out the Google form of the MCQ, they can disconnect from the meeting and solve the MCQ. Okay. And tomorrow is the last day of this course. So day 10 will be there. So we request all the participants to be at 10 a.m. The link will be remaining same. So we request you all to be kindly present for that. Tomorrow from 2 to 2:30, there will be a valedictory session and a feedback session where we will be asking the participants to provide their verbal feedback for the course. So we request you all the participants to please be present in that valedictory session so that we can note down all the important feedbacks and the scope of improvements from you in order to improve in our future. Thank you all. So, dear participants, you can disconnect from the meeting link. The link will be deactivated in another 2 minutes. Thank you.
Thank you, ma'am.
Thank you.